Welcome back to Sleep Nova. Sit back, relax, and enjoy the show. A lone human body drifts in the silent darkness, high above the blue curve of Earth. Eyes wide, heart calm, they float effortlessly, suspended between the radiant planet below and the endless stars above. The only sound is their own breath, a gentle rhythm in the vacuum of space. Below, a fragile swirl of whites, blues, and browns, the Earth glows against the black cosmic sea. In this weightless moment, time itself seems to pause. There is only the rise and fall of breathing, the steady beating of a heart, and the profound sight of home hovering in the distance. In this quiet ballet of body and cosmos, a sense of both awe and belonging washes over them. They extend a hand, as if to touch the curved horizon of Earth far beneath. Cities sparkle faintly on the night side like scattered embers. Daylight paints clouds and oceans in brilliant hues. The atmosphere is a delicate halo, a thin shell of life clinging to a solitary world. From up here, there are no borders, no sounds of human hustle, just a silent, spinning sphere and the tiny figure gazing down, wondering. The human body, unbound from gravity, moves with slow grace, a gentle turn, a slow tumble, like an infant cradled in the womb of space. For as long as humans have walked the Earth, we have dreamed of this view. We have imagined ourselves among the stars, our stories reaching upward when our bodies could not. Ancient poets and storytellers looked up at the night sky and populated it with their hopes and gods. Perhaps this drifting soul remembers some of those old tales, of a Chinese goddess, Chang'e, carried to the moon by the elixir of immortality, of the winged Icarus who flew too close to the sun, of heavenly ladders and chariots carrying mortals skyward in mythic flights. In every culture, the sky was the realm of the divine and the impossible, and yet we were drawn to it, hearts full of longing. Now here, floating above Earth, myth becomes tangible truth. The stars no longer feel out of reach. The person floats as if in a dream, fulfilling an ancient yearning written into our very bones. In this moment, the boundary between dream and reality blurs. The body recalls stories of those who dared to imagine this weightlessness. Perhaps it remembers the science fiction tales devoured in youth, intrepid travelers in rocket ships, space stations spinning with artificial gravity, cities on Mars beneath pink skies. Those fictions were the seeds of our reality. They carried the torch of the old myths, keeping the spark alive through centuries until technology could catch up. The lone figure in orbit closes their eyes, feeling the warmth of the sun on their face, unfiltered by any atmosphere. They think of those who imagined this moment long ago. A writer in ancient Greece who told of a ship whisked to the moon by a waterspout. A Renaissance astronomer who wrote of demons carrying voyages into the heavens. A 19th century novelist who fired a space capsule from a giant cannon. All those dreams, absurd and beautiful, have led to this quiet instant above the Earth. Slowly, they open their eyes again. Tears would float free in this microgravity, but there is only wonder, no sadness. Below, Earth turns, and with it turn the ages of human history that led us here. How many generations looked up at the moon and stars with longing? How many nights on the plains or in ancient cities did our ancestors whisper stories about living in the sky? It was a collective dream shared across cultures and time, a dream that one day, somehow, we might slip the surly bonds of Earth and make our home among those lights in the night. And now the dreamer is awake in the heavens. The human body in space is real, fragile, miraculous. As they take it all in, the silent symphony of Earth and stars, a thought arises, gentle but persistent. Can we live in outer space? Floating above the only home we've ever known, the question feels both urgent and natural. The body drifts on, turning slowly end over end, and the Earthrise in their visor reflects the dawn of a new idea. Perhaps our home is not just that distant blue sphere, but also the space around it, the moon, the planets, and even the stars beyond. Perhaps this is the first step of a long journey outward. In the depths of those eyes staring into the cosmic abyss, there is courage and curiosity. The same traits that drove explorers across oceans now carry us beyond our atmosphere. The human in orbit gently pivots to look away from Earth, out into the star-speckled darkness. There are no familiar landmarks there, only infinity. It is beautiful and terrifying all at once. The Milky Way spills its pale light, and one cannot help feeling both tiny and grand. Tiny as a speck in an unfathomable expanse, yet grand as a bearer of consciousness, a piece of the universe that can behold itself. They stretch out their arms as if to embrace the cosmos. In the emptiness, one feels an unexpected fullness, a connection to all of humanity, to those on Earth below, and to those who will someday venture further. Floating here is not an escape, but a homecoming of a different sort, a return to the stars that forged the atoms in our bodies. We are children of the universe, and now, finally, we have begun to come home. The radio crackles with a distant voice. Mission control, a reminder of the links that still tether this Voyager to Earth. The spell of absolute solitude gently breaks, but the sense of reverie remains. As the astronaut responds and prepares to return to the space station nearby, their heart lingers on that profound question. Can we live in outer space? Not just visit for moments like this, but truly live, work, love, and build a new world out here. In the serene silence, with Earthlight glinting off their visor, they know the answer lies ahead, in both dream and effort. Humanity's story has always been one of pushing frontiers, of making the imagined real. The body takes one last slow turn, Earth filling the view once more. The journey back to the station is brief, a small thruster firing to guide them home. But the mind travels far beyond, envisioning what life among the stars might one day mean. With a gentle grasp, the astronaut re-enters the airlock of the orbiting habitat. One small step in microgravity, one giant leap carried in the heart. As the hatch closes and pressurizes with a hiss, they hold on to that feeling of floating freely above the world. It is the feeling of a dream becoming reality, of ancient myth finding new form, of humanity extending its reach. It is the beginning of a story of whether we can leave our cradle and learn to live in the cosmos. Inside the space station, the astronaut removes their helmet. Sweat floats as tiny droplets before being caught by a cloth. They tether themselves to a wall, though here it is just another surface, to keep from drifting. As they pause, they recall how impossibly distant such a moment would have seemed to our ancestors. Yet this station, this life in orbit, did not appear overnight. It was built on generations of dreaming and decades of trial and error. The notion of living away from Earth has always been with us, first as myth and fantasy, and then as concrete science and engineering. Centuries ago, long before the first rocket pierced the sky, people were already envisioning voyages beyond Earth. In ancient China, storytellers recounted the legend of a civil servant, one who fastened rockets to a chair in a bid to reach the stars, a mythic tale of ambition that hints at our age-old desire to escape gravity. The Greeks told of the philosopher Lucian's imaginary trip to the moon, carried by a great whirlwind, discovering odd lunar societies. A playful fantasy, but one that treated the moon as a place one could truly visit and even live. In the 17th century, Johannes Kepler wrote a story, Somnium, about a journey to the moon assisted by supernatural forces, in which he speculated earnestly about moon-dwelling creatures and the challenges of surviving in lunar conditions like cold and vacuum. Each tale, from the whimsical to the scientific, added a brushstroke to a growing portrait of life beyond Earth. The dream only intensified as knowledge grew. By the late 19th century, Writers like Jules Verne took these dreams and grounded them in calculation and steel. Verne's novel, From the Earth to the Moon, imagined a colossal cannon shooting a crew in a bullet-shaped capsule into space. It was fanciful in execution, yet remarkably prescient in details. He calculated trajectories and launch sites, inspiring real engineers. Around the same time, H.G. Wells mused about anti-gravity metal in The First Men in the Moon, conjuring an underground lunar civilization. These early science fiction visions served as both entertainment and blueprint. They whispered that living in space was not just myth, it could perhaps one day be real. As the astronaut secures their helmet to the wall, they recall another figure who straddled the line between fiction and reality, a Russian schoolteacher named Konstantin Tsiolkovsky. In the late 1800s, Tsiolkovsky, inspired by Werner's stories and the gleam of the stars above, began to work out the mathematics of spaceflight. He dreamed of weightless habitats orbiting Earth, where people would float in cylindrical shells and grow plants in greenhouses to survive. Earth, he wrote, is the cradle of humanity, but one cannot remain in the cradle forever. That rallying cry from a quiet man in a provincial town became a mantra for the new century. Across the ocean, an American named Robert Goddard and a Transylvanian-born Hermann Oberth also believed passionately that humanity could break free of Earth. They built small rockets, tested strange fuels, and scribbled equations late into the night, often ridiculed for their moon-mad ideas. But they persevered. The space station vibrates ever so slightly as a guidance thruster fires to adjust its orbit. The astronaut smiles, thinking how that gentle push traces its intellectual lineage back to those early rocket pioneers. By the mid-20th century, rocketry had leapt from theory to practice, though initially for war. The roar of the V-2 rockets over Europe during World War II was a sinister harbinger, but in the rubble of that conflict, the seeds of human spaceflight were found. Engineers who once built weapons turned their eyes upward, repurposing technology for exploration. In a single generation, humanity vaulted from dreaming about spaceflight to actually riding fire into the heavens. It happened on a spring day in 1961. A Russian named Yuri Gagarin squeezed into a tiny spherical capsule atop a towering rocket. With a thunderous launch, he became the first human to leave the Earth's embrace, orbiting the planet in 108 minutes. As he gazed down on the Earth, the first of us to see our world from above, Gagarin reportedly marveled at the beauty of it, at the thinness of the atmosphere. When he safely returned, the world erupted in celebration and astonishment. The impossible had become possible. The cradle's grip was loosened, if only for a single orbit. After Gagarin's leap came a cascade of milestones. Americans sent John Glenn orbiting soon after, and just 8 years later, in 1969, Neil Armstrong's boot pressed into the grey dust of the moon. For a moment, it seemed all of humanity stood on that desolate lunar sea with him, hearts pounding as he uttered about one small step and a giant leap. In that grainy broadcast, the ancient dream of living in space found its first foothold on another world, if only briefly. The Apollo astronauts spent mere hours or days on the moon, camping in fragile landers. Yet, as they looked up at the marble of Earth hanging in the black sky, they carried back a message: that we could physically exist on another world, albeit for a short time, and that our own planet was both beautiful and heartbreakingly isolated. Back on Earth, those brief extraterrestrial adventures ignited imaginations anew. In the 1970s, even as the moon missions ended, thinkers like Gerard O'Neill asked, why not build our own colonies in space? Why only visit moons and planets when we could create habitats free floating in the void, crafted by human hands to be like Earth? Concepts for gigantic rotating cylinders in space, miles long and miles in diameter, sprang from serious studies at universities and space agencies. These cylindrical colonies, O'Neill cylinders as they came to be known, would spin to provide artificial gravity on their inner surface. Inside, they envisioned entire landscapes, Fields of green, towns along a curved horizon, perhaps even artificial lakes and clouds, all enclosed by metal and glass and shielded from deadly cosmic radiation. Artists painted these dreams in vibrant detail, children flying kites in alien sky-blue light, families picnicking in orbit with the Earth itself, a distant jewel in the sky. These were no mere fantasies. They were backed by thick engineering reports, calculations of how many tons of metal and water would be needed, how to harvest materials from the moon or asteroids to build them. For a moment in human discourse, living in space was not just a far future possibility. It felt on the cusp of tangible planning. But reality, as always, proceeded in smaller steps. The astronaut aboard our modern station knows this intimately. Before humanity could build floating cities, we had to learn how to survive for days, then weeks, then months beyond Earth. The 1970s brought the first true space habitats, though humble. The Soviet Union's Salyut stations and America's Skylab were early attempts, a few modules linked together, cramped and Spartan inside. Cosmonauts and astronauts lived in these tin can homes for a few months at most, learning how to sleep in weightlessness, how to eat, how to stay sane in a very finite, up-downless world. Skylab, with its roomy workshop, even allowed 3 men to spend about 3 months in orbit, conducting experiments and gazing back at Earth through a golden window. They famously snuck in time to simply watch the Earth go by, and once, feeling overwhelmed by ground control's busy schedule, they took an impromptu day off, a gentle rebellion reminding everyone that humans, not robots, lived up there with human limits and needs. Lessons accumulated. In the 1980s and 90s, Soviet cosmonauts aboard the space station Mir pushed human endurance further. They stayed not just months, but over a year in space, showing that our bodies and minds, while strained, could adapt to long durations away from Earth. Mir was a true long-term home off Earth's surface, rickety at times, cluttered with equipment and the personal touches of its crew, photos of family taped to walls, a guitar floating in a corner, occasional motes of bread or dust caught by sunlight in the cabin air. It was in those years that living in space transformed from an abstract question into a day-to-day reality for a select few. People learned to function in microgravity not as an expedition, but as a lifestyle, albeit a challenging one. Men and women orbited Earth for hundreds of days, experiencing how solitude and microgravity affect hearts, bones, and minds. They found ways to cope and flourish, exercising their muscles with rubber bungees and treadmills, sharing jokes and routines to keep morale high. All these moments, the triumphs of Gagarin and Armstrong, the slow, steady work aboard Salyut, Skylab, and Mir, were stepping stones. They answered some basic questions and raised new ones. We learned that humans could eat, sleep, and work in microgravity. But what about truly living, starting families, building societies? That remained the stuff of speculation, even as the practical groundwork was laid. The International Space Station, where our astronaut now floats, is the heir to those early stations. It is a gleaming lattice of modules, as long as a football field, assembled piece by piece by many nations. Since the year 2000, there has not been a single day when humans were not living in orbit. Generations have now been born who have never known a time when the glow of an inhabited spacecraft couldn't be seen moving across the night sky. So, as the astronaut secures their gear and moves through the station's corridor, they are walking, or rather drifting, through the halls of what was once pure fantasy. Here, living in space is ordinary in its basics. There are bunks for sleeping, a galley for preparing meals, laboratories full of humming machines. And yet, it is extraordinary too. Just outside the thin walls lies vacuum and infinity. Every inch of this habitat is a triumph of human ingenuity and cooperation. Water is recycled from breath and sweat. Oxygen is generated from water by electrolysis, and a carefully maintained balance of air keeps them alive. The station is a bubble of Earth's environment transplanted into space, a tiny, fragile bubble that requires constant vigilance. It took thousands of people on Earth to design, build, and maintain this lifeboat in the void. In floating here, among humming computers and the soft whir of air filters, the astronaut feels the presence of all that history. The myths, the stories, the equations scribbled on paper, the fervent work of engineers, the bravery of early spacefarers. This place, this moment, is built atop all of that. And still, it is only the prologue to a much grander saga that is yet to come. For the question remains, can we truly live in outer space? We have learned how to survive for a while. We have visited the moon and inhabited low Earth orbit continuously, but survival is not the same as living fully. To live in outer space means to make it our home, not just a campsite. It means confronting challenges our ancestors never faced and solving problems our legends never imagined. The astronaut gently propels themselves toward the observation cupola, a domed window on the space station that offers a panoramic view of Earth and the cosmos. As they peer out at the blue planet below, now passing over a sunlit ocean, they consider how far we've come and how far we have yet to go. The station's orbit traces a path through day and night, and each sunrise illuminates the curved horizon with a golden glow. With each dawn, a new chapter in the dream of space living begins, built on the foundation of all the history that got us here. We are on the threshold. In that astronaut's reflection is the face of humanity, filled with determination and curiosity. The ancient dreams have led us to the present reality. Now the present reality asks us to dream again, this time with hard-earned wisdom guiding fancy. The journey to truly live in space is underway, and it carries all of our past with it, mythic heroes and real ones, propelling us toward the future. Humanity did not leap into the cosmos without introspection. Back in the early 21st century, as it became clear that technology might soon allow migrations beyond Earth, we faced pivotal questions. Who gets to go? On what terms? In the beginning, spaceflight was the domain of a few highly trained astronauts, chosen by governments through rigorous criteria focusing on skills, fitness, and mission needs. They were envoys of all humankind, but they were also elite, representing nations and carrying the prestige of their homelands into orbit. As the dream of settling space moved from fiction toward reality, it sparked both excitement and anxiety in societies worldwide. Some feared a future where only the rich or powerful could escape to space habitats, leaving the less fortunate behind on a troubled Earth. Science fiction had explored those dystopias in cautionary tales of orbiting gated communities, and society took those warnings to heart. It was crucial to ensure that space did not become just another arena of inequality. Early efforts to democratize space access began with symbolic gestures. An international teacher in space, artists sent to the space station to share the experience through creativity, a contest sending a teenager's science experiment to orbit. When private citizens, space tourists, started visiting the International Space Station, it opened a new chapter. They were wealthy adventurers, yes, but their very presence signaled that space was slowly opening beyond career astronauts. Over time, companies emerged promising to take people to orbit or the moon if they could afford a ticket, much as commercial airlines had done for air travel. Prices were astronomical at first, but tended downward. A new question arose. Should there be subsidies or lotteries to ensure not only millionaires could go? Some governments indeed began sponsoring seats for teachers, poets, or everyman citizen astronauts, emphasizing that space is for everyone. When plans for the first Mars colony were announced, the application process was broadcast globally. Thousands of hopefuls from every country sent in videos and essays, volunteering for what might be a one-way trip, at least for many years. Selection committees labored to balance skills: farmers, engineers, doctors, technicians, psychologists, with human elements. Could these people get along in a tin can on a hostile planet? Did they represent the diversity of Earth's peoples? the world watched and debated. Reality TV shows even cropped up dramatizing the selection, which some criticized as trivializing a solemn endeavor. But it showed that humanity at large was invested. Going to Mars was not just a governmental project, it was a human project. Ethicists weighed in. How do we obtain informed consent for a mission with such uncertainty and risk? Is it right to let people effectively exile themselves to a barren world? Others argued it was akin to the great seafaring explorations or pioneer migrations of history. Bold and dangerous, yes, but driven by our intrinsic push to explore and settle. The difference? Those historical colonizations often displaced or harmed others, native peoples, exploited labor. On Mars or the Moon, there were no indigenous people, only an environment and perhaps microbial life to consider. So our moral focus shifted to preserving those environments scientifically and not contaminating them recklessly. Robotic probes had tried to ensure Mars was mostly sterile before humans arrived, but people inevitably carry Earth microbes on their skin and clothes. Thus, protocols were in place. Mars habitats would be isolated and waste sterilized. The search for Martian life would continue, so that if we found even a hint of native biology, we could adapt our plans to avoid harming it. Some advocated that certain zones of Mars be designated off-limits, planetary parks for science only. We would, in effect, impose a principle of do no harm as much as possible, extending respect even to a potentially lifeless but scientifically precious world. Within human society, there was an understanding that those who go to space carry the responsibility of all humans. Early Mars settlers took oath-like pledges reminiscent of explorers' vows. They knew their actions could set precedents. If they claimed territory or behaved recklessly, it could sow conflict. Thus, international treaties were reaffirmed and extended. No nation can own celestial bodies. Mars and beyond belong to all humankind. Any colony would ideally operate under a framework that included many nations or a new collective governance. But how to govern a colony millions of kilometers away? Some on Earth fearfully imagined a Mars that one day might declare independence and spark Mars versus Earth tensions. Others were optimistic, picturing inclusive political structures, a kind of United Nations of space, where Earth nations and off-world colonies sat together. In any case, these concerns made one thing clear. Living in space isn't just engineering, it's society building. We would need new laws and norms. If a child was born on Mars, what citizenship would they have? Earthling or Martian? Early on, it was decided they'd hold the citizenship of their parents' home nation, or perhaps a special Earth passport, until Martian self-governance developed. And what about justice in space? An international space treaty was expanded to cover crimes or disputes, a framework where Earth-based courts might have jurisdiction until colonies set up their own legal systems consistent with human rights. Who gets to shape all this? By necessity, those who went first shaped much of it. Their successes or failures would influence public opinion and policy. Early Mars crews and space habitat residents made a point of broad transparency, broadcasting their daily lives, the joys and struggles, back to Earth. This open diary of colonization helped Earth's public feel invested and included, not left behind. It wasn't us and them, but rather we are doing this together, step by step. When a crew member on Mars expressed homesickness looking at Earth in their sky, or two settlers in a moon base had a personal conflict they needed to resolve, those stories, shared carefully, humanized them. People on Earth realized these pioneers were not superheroes or distant gods. They were people, fallible, relatable, courageous people, just in a very novel situation. The ethics of selection gradually gave way to the ethics of integration. As people began living off Earth for longer, how would they remain part of humanity's shared culture? The lines of communication, education, and art became crucial. Earth institutions began to include off-world history in curricula as soon as colonies formed. A child on Earth might learn about the first Martian colony the way they learned about ancient Rome, taking pride in it as part of human heritage. Meanwhile, children on Mars or the Moon studied Earth's cultures and languages deeply, knowing that is where humanity grew from. There was a deliberate effort to prevent an us versus them mentality from forming. Still, differences emerged with time and new questions. If a Mars-born person found Earth's gravity too heavy to live comfortably, would they be considered disabled on Earth or simply adapted to Mars? If an orbital habitat chose a novel form of government, say, a direct digital democracy in their small community, would Earth nations recognize it? As human society diversified into different gravities and environments, tolerance and pluralism had to expand as well. We had to accept that human could encompass someone who's never felt 1G, or whose calendar was 24.6 hours long, or whose night sky lacked a moon but featured the rings of Saturn. In those early shaping years, deciding who got to live in outer space and under what rules was guided by something profound, a sense that in space, we must represent the best of us. Perhaps that was optimistic, but it was a self-fulfilling aspiration. The people who chose to leave Earth largely did so out of idealism and scientific passion. They carried that idealism with them. They named their new habitats things like Harmony or Shackleton after explorers, or gave them names from many languages to reflect unity. They drafted charters echoing the Universal Declaration of Human Rights, ensuring that regardless of the strange new circumstances, fundamental human dignity was upheld. Mistakes happened. No society, new or old, is perfect. But a conscious effort was made not to repeat historical injustices in this fresh arena. For example, when corporations attempted to monopolize asteroid mining zones or patent essential space resources, international bodies and public outcry pushed back, crafting agreements, like updated outer space treaties, to treat these resources as the common heritage of mankind. Space belongs to all humanity was not just a slogan, it was written into policy. There was no space police to enforce these ideals beyond the reach of Earth, but collective pressure and the moral authority of the international community generally held sway. After all, early space settlements still needed Earth's support, goodwill, and markets. Going rogue was not in their interest. Thus, through fits and starts, humanity navigated the ethical landscape of becoming multiplanetary. The story of who lived in outer space became, ultimately, a story of all of us. In time, millions might live off-world, but in those first few decades it was dozens, then hundreds, then thousands. Each one of them was aware they were a representative. When the first baby was born on the Moon, the parents allowed a short live transmission of the child's first cry. People around the globe cheered and wept in unison. It was as if a member of every family had been born out there. When the first Martian settlement held a vote to elect a local council, Earth media broadcast it as a global event, democracy's first off-world election. Such moments were celebrated not as alien, but as extensions of human civilization. By the time orbital habitats and Mars cities were truly self-sustaining, the question, who gets to live in outer space, had evolved. It was no longer just about selection or privilege. It became about preparation and opportunity. Schools worldwide began to tell children that moving to space or another planet was a viable option in their future, something to aspire to, just like any career. What do you want to be when you grow up? Might now be answered by a child in Nairobi or New York with a Mars agronomist or an orbital architect. To make that real, scholarships and training programs emerged so that not only the wealthiest nations' citizens could go to space. Space agencies formed international astronaut corps for planetary missions, pulling talent from a broad pool. If space was to be humanity's new frontier, then humanity as a whole would have a stake in it. In parallel, those who ventured outward never forgot their roots. Most spacefarers developed an even stronger environmental ethic for Earth after seeing it from afar. Many who returned from assignments on Mars or the Moon became powerful advocates for protecting Earth's ecosystems, armed with tech they'd developed for closed-loop survival in space, efficient recyclers, indoor farming techniques that could help communities on Earth live more sustainably. Far from escaping Earth's problems, they often returned with fresh perspective to help solve them. Thus, the relationship became symbiotic. Earth nurtured space settlements with people, culture, and supplies. Space, in turn, gave Earth innovations, perspective, and hope. It wasn't always smooth. There were episodes of public doubt, moments of tragedy, an accident in space that claimed lives, prompting reflection on risk and purpose, and periodic criticisms that money spent on Mars could be better spent on earthly hunger or disease. But the momentum, once started, was hard to stop. The dream was too potent, the potential too great. In one telling episode, a private consortium announced plans to establish a luxury space resort only for the ultra-wealthy, essentially a gilded orbital refuge. The backlash was swift and fierce. Media and citizens alike condemned it as against the spirit of humanity's shared journey. The consortium rebranded the project, adding scientific facilities and opening some spots for researchers and students, making it not just a pleasure dome, but a part of the collective effort. The lesson: humanity would not embrace a future in which space was a lifeboat for the few or a playground of privilege. If we go to space to thrive, we go as a human family, messy, diverse, striving to be just. By the time the first multi-family habitats in orbit and the first Martian towns were thriving, the ethics of selection had transformed into something akin to immigration on Earth. There were requirements and processes, but the guiding principle was that anyone could aspire to go if they prepared and contributed. Perhaps a day will come when leaving Earth is as routine as moving to another country, motivated by jobs, adventure, or the simple desire for a different sky. If that day arrives, we will remember the ethos established when the Enterprise was fragile, that we are caretakers of each other, whether Earthborn or spaceborn, and that we owe each other empathy across the void. Those first brave souls in off-world colonies set the tone, one of cooperation, equality, and awe. They wrote in their journals about feeling like tenants of the solar system, all of us, and hoping their work would benefit everyone, not just themselves. One early Mars settler, standing under the pale pink Martian sky, said during an interview, "Mars is not a refuge or a fortress for a few. It's a new chapter for civilization. We're here to open the door for everyone else, whenever they're ready." It was a sentiment that resonated widely on Earth and became a guiding star in space policy. Now, looking back on those times from our vantage in the future, we see it wasn't perfect, but somehow we avoided the worst pitfalls. The question of who gets to live in outer space gradually shifted from the hands of a few gatekeepers to a more organic flow of migration. And as more people went, the line between us on Earth and them in space blurred. They stepped into the void, armed not only with technology, but with a mandate to uphold humanity's shared values in each new habitat. And so, as the first crews settled into their permanent spaceborne homes, they carried with them the hopes and principles of the whole Earth. We became one community spread across many places. With that unity in diversity, we carried forward into the following decades, ready to face the practical and philosophical challenges of actually building lives beyond our home world. Morning on the space station does not arrive with the sun. Sunrise and sunset happen every 45 minutes here, but by the schedule set in Houston and Moscow. The astronaut glances at their wristwatch. It's morning by agreement, though outside the window the Earth below is bathed in midday light. They float over to a small compartment, about the size of a telephone booth, which serves as their sleeping quarters. Inside, a sleeping bag is pinned to the wall. Last night, They drifted into slumber, zipped inside that bag, kept from free-floating by straps. In microgravity, there's no tossing and turning in bed. Every surface can be a bed if you let it. Some nights they simply tethered themselves and closed their eyes, letting their arms float upward in the simian hunch posture that bodies naturally take without gravity, almost like a fetus curled in amniotic fluid. It's oddly comfortable, sleeping as if back in the womb of weightlessness. Emerging from the sleeping bag, the astronaut performs a familiar dance with morning hygiene. There is no running water. A blob of water squeezed from a pouch hovers in the air until caught on a washcloth. They rub it over their face and scalp. No rinse shampoo helps keep their short-cropped hair clean. An electric razor floats at hand, but shaving must be done carefully near an air vent that can suck in the clippings, lest tiny hairs wander into instruments or lungs. There's no shower to stand under. One couldn't even stand, and water would spray in every direction. Instead, cleanliness is maintained through sponge baths with wet towels. It's a reminder that even the simplest Earth routines must be reinvented out here. Dressed in a fresh shirt and pants, clothes are worn a few days, then packed away as trash to be incinerated on re-entry. Since washing machines are a luxury for another time, the astronaut makes their way to the galley for breakfast. Breakfast might be scrambled eggs, in powdered form, revived with a squirt of water, or perhaps a pouch of yogurt and dried fruit. Food in space is a careful affair. Every morsel must be contained. In front of them, they velcro their meal packet to the table so it doesn't drift. Using a small utensil, which sticks magnetically to the tray between bites, they savor the food. It's not gourmet, but the engineers have come a long way from the paste in tubes that early cosmonauts endured. There are dozens of menu items now. Thermostabilized stews, freeze-dried fruits, even occasional treats like irradiated smoked turkey or a brownie for dessert. Still, something is different. Microgravity has caused fluid to shift upward in their body, subtly congesting their sinuses as if with a mild cold. With a stuffy head, taste is blunted. Many astronauts crave hot sauce or strong spices to lend zing to these meals. A beloved item on the station is a bottle of pepper sauce. A few drops, carefully applied and stirred so they don't float off as burning droplets, can make rehydrated eggs taste almost like home. As they eat, they gaze out a nearby viewport at Earth. Drifting over the Middle East now, golden deserts and a ribbon of the Nile, this view never ceases to captivate. This daily communion with Earth below is more than recreation. For many spacefarers, it's a mental lifeline. They might spot their country, even their hometown, in a single sweep of the eye. It brings perspective and comfort, a reminder that though they live in the sky, they remain connected to humanity on the ground. Breakfast done, the astronaut cleans up, stowing wrappers and pouches for disposal. Now the workday begins. On the schedule, maintaining the life support systems and conducting several science experiments. But before any heavy work, there's a crucial daily task: exercise. In orbit, without gravity's pull, the human body begins to change in subtle and not so subtle ways. Our bones and muscles evolve to work constantly against weight. Take that away, and they start to weaken at an alarming rate. Already, after some weeks in space, our astronaut has experienced it. Legs thinning a bit, muscles not used for posture starting to shrink. Without intervention, an astronaut can lose as much as 1% of their bone density per month, a rate of loss that would be the envy of osteoporosis on Earth, and their muscles, especially in the legs and back, can atrophy just as quickly. So each day, they dedicate about 2 hours to vigorous exercise. The astronaut moves to a corner of the station where a strange-looking treadmill is mounted on the wall, though in microgravity, wall and floor mean little. They buckle into a harness that straps them to the treadmill with elastic bands. Otherwise, they would float away with each step. Once secured, they begin to run. It feels at first like running with a heavy backpack, necessary to simulate the feeling of weight on their feet. Around them, equipment rattles softly with each footfall on the moving belt, a drumbeat in the quiet station. Despite the inconvenience, the astronaut welcomes the exertion. Their heart pumps faster, their muscles strain and sweat, and for a moment, they feel almost normal, almost back on Earth jogging in a park. Yet a drop of sweat breaks free from their brow and floats before their eyes, a glittering reminder that this is not Earth. They catch it with a towel and continue. After cardiovascular exercise, they switch to the resistance machine, a marvel of engineering called ARED, Advanced Resistive Exercise Device. It mimics weightlifting through vacuum cylinders that provide adjustable resistance. Here, they lift weights to keep upper body and core muscles strong. They do squats and deadlifts of a sort, the device pulling against them as they push. The strain on muscles feels satisfying. This routine will, with luck, ensure that when they return to Earth's gravity one day, they won't collapse under their own weight. Without these measures, returning astronauts could struggle to walk or stand as their reconditioned bodies re-encounter gravity. Even with diligent workouts, many astronauts still need help standing when they first land. Muscles tremble and blood pressure can drop, causing dizziness until their cardiovascular system readapts. Exercise also helps in other ways. It gets the blood flowing, mitigating the fluid shifts that cause puffy faces and skinny bird legs. In microgravity, without gravity drawing fluids down, blood and water in the body move upward. Faces swell slightly. Sometimes, astronauts look like they have a constant mild sinus congestion, while their legs, not bearing weight, lose fluid and slim down. They joke about the puffy head, bird legs syndrome. But behind the joke is a real concern. That upward fluid shift can increase pressure inside the skull and on the back of the eyes. Some astronauts, especially on long missions, have experienced changes in their vision, flattened eyeballs and swollen optic nerves, a condition being studied closely. Doctors call it spaceflight-associated neuroocular syndrome, and it's one of many puzzles we must solve for longer space living. Our astronaut diligently performs extra eye exams when asked, pressing their face against a device that uses ultrasound to image their retinas. They know that the very shape of their eyes might be altered by this weightless life. With exercise done, they towel off and float to the next task. A science experiment awaits, growing little plants in a microgravity greenhouse. They open a small chamber where delicate sprouts of lettuce are thriving under pink LED lights. Tended carefully, these greens will be part of the crew's diet in a few weeks. A welcome crunch of fresh salad amid packaged foods. More importantly, they are a test of sustaining life off Earth. The astronaut injects water into the roots and checks sensors. The sight of the tiny leaves brings a smile. Even a bit of green, a bit of life from soil, profoundly lifts the sterile mechanical atmosphere of the station. It reminds them of a garden on Earth, and for a moment, the station feels more homely. This quiet interlude with the plants is broken by an alarm, just a scheduled reminder for a medical check. It's time to collect a blood sample for a study on how the immune system behaves in space. Microgravity affects nearly every bodily system. The immune system can get a bit confused. Some astronauts find latent viruses like shingles reactivating under the stress and altered physiology of spaceflight. Blood and saliva samples help scientists track these changes. With practiced efficiency, the astronaut draws a vial of their own blood, labels it, and stores it in a freezer that will keep it for return to Earth analysis. They make a log entry on a computer describing how they feel today. Mood and cognition are also under the microscope. Spacefarers often report a certain euphoria at first, the so-called overview effect of seeing Earth as one unified entity can fill one with unexpected peace and planetary love. But beyond that, as days turn to weeks, they experience the full spectrum of human emotion. There are days of excitement, days of monotony, moments of irritation or longing for home, bursts of camaraderie and laughter with crewmates, and quiet periods of introspection staring out the window. They might joke over dinner and music one night, and the next quietly miss the feeling of wind and rain on their face. In the close quarters of the station, about the internal volume of a large house, but much of that filled with equipment. Privacy is scarce. Each crew member has their little sleeping nook, but otherwise they are almost always within earshot of each other. Minor conflicts can arise. A mislaid tool or a forgotten checklist can spark annoyance that must be carefully managed. They are professionals, trained to cooperate, but they are human too. On Earth, one could walk away after an argument. Here, there's nowhere else to go. So communication and patience become their own vital life support systems. Our astronaut scribbles a candid thought in a private journal. Dreamed of the forest behind my childhood home last night. Could smell the pines. Woke up floating. These journals are encouraged by psychologists. They give crew members a safe outlet and provide researchers insight after the mission into their mental states over time. It's all part of learning how isolation and confinement affect humans when it's not just a week-long mission, but months and eventually years. The workday continues. Maintenance is constant. Filters need cleaning, devices must be recalibrated. The station is like a small town with a never-ending to-do list. Air and water systems to check, communications gear to update, scientific apparatus to tend. In between tasks, the astronaut steals glances out the window. The station passes over the Pacific now. A broad swath of ocean shimmers under the sun. In the distance, a curl of a tropical cyclone draws their eye. A massive weather system silently swirling. They snap a photo. Capturing Earth's wonders is a favorite pastime and also an important science activity. Those photos help track environmental changes and, for the astronaut, taking them is a form of artistic expression and connection to home. By late afternoon, the crew reconvenes for a planning meeting with Mission Control. A disembodied voice from home, running through tomorrow's agenda and receiving updates about today's. Though separated by 400 kilometers of void, the astronauts and ground teams form a single community. They even share jokes over the loop. Mission controllers know the value of morale. One controller reads up a bit of news from Earth. A major sports finals result. A popular song topping the charts. A holiday message from a school. These little things mean the world to those off the world. It is a reminder that life on Earth flows on, and they are still part of it in spirit. Evening comes. Again, only by the clock. Since out the window, one might see the sun dipping toward a horizon and then rising again in a span of an hour and a half. The crew gathers for dinner. They drift around a makeshift table, securing their food packets with Velcro. Tonight, it's something resembling stew and rice, with peach cobbler for dessert, a special treat sent up in a cargo ship. They clink their plastic water pouches in a toast. To another successful day in space, someone quips. Laughter fills the module, echoes soft against the metallic walls. This simple camaraderie is as vital as oxygen. They share stories. Perhaps an old astronaut recounts a tale of Mir or the space shuttle days. A younger crewmate might talk about their children back home, drawing a picture of Mummy floating in space. After dinner, they indulge in a rare pleasure: music. One crew member brings out a guitar that has been aboard the station for years, strumming it in the air. The acoustics in the cramped node are surprisingly good. Our astronaut closes their eyes and listens as a familiar melody, perhaps a rendition of Space Oddity or a favorite classical piece, reverberates through the station. In microgravity, the notes hang and gently fade without the weight of gravity to dampen the instrument. It's a gentle concert for 6 souls drifting above the Earth. Some quietly hum or sing along. Others tap their feet against a handrail in time, or they would if feet stayed on the floor. For a moment, they could be in a living room on Earth, friends enjoying music after a day's work. But the view, the view from the cupola, betrays their extraordinary locale. The Earth at night, with city lights twinkling like constellations of their own, sweeps past under a veil of atmospheric glow. Stars beyond shine cold and steady, with no twinkle here, without air, a bed of diamonds on black velvet. As the music winds down, each person drifts to their own evening ritual. One might call their family via an IP phone link, speaking to a spouse or child, the signal bouncing through satellites to bridge Earth and sky. The time delay is negligible at this low orbit, making the conversation feel almost normal, except for the odd remark like, "I saw a beautiful sunrise an hour ago," while family replies, "But it's still afternoon here." Another astronaut might watch a movie on a laptop, floating in their sleeping quarters, a bit of escapism that momentarily transports them to a gravity-bound world through fiction. Our astronaut decides to write an email or two, one to an old friend, describing the thrill of seeing lightning storms from above, another to mission planners, with a suggestion about improving the plant watering system. They know that to truly live in space one day, the little things will matter. The ergonomics of a zero-G watering can, the recipe for a crumb-free bread that doesn't make a mess. Astronauts prefer tortillas for this reason. Life out here is a mosaic of such details, each addressed through trial and experience. Finally, it's time for bed. They retreat to the sleeping nook, where a small photograph of their family is velcroed to the wall next to a plush toy floating as a tiny guardian. As they zip into the sleeping bag, they feel the day's experiences gently replaying in mind, the effort of exercise, the wonder of the Earth's panorama, the quiet pride in another day off Earth. They know their calcium supplements and workouts will help keep their bones strong, that the filtered air they breathe is keeping them alive, that countless systems hum in the background to simulate an Earth-like bubble. It's a delicate equilibrium. Earlier, they had to replace a CO2 scrubber canister because carbon dioxide was creeping up. Removing CO2 is literally a matter of life or death in an enclosed habitat. Such tasks become routine here, as crucial as refilling a car's gas tank on Earth. In their mind, they ponder the facts of their own body. Their heart has gotten a bit lazy in microgravity, not pumping blood uphill as it once did. It may have shrunk slightly in muscle mass over the mission. Their bones in the lower body are shedding calcium, some of which ends up in their urine, hence the risk of kidney stones, mitigated by staying hydrated and taking potassium citrate. They recall being part of an experiment where ultrasound tracked how the spine's vertebrae separate slightly in microgravity, making them a few centimeters taller temporarily, but often giving them backaches from stretched ligaments. These are all pieces of the new normal for humans in space. None of it has been insurmountable so far, but as we contemplate living years, perhaps lifetimes, off Earth, these issues loom large. We would need artificial gravity or other innovations if humans are to live and raise children beyond Earth for generations. Our bodies, as they are now, are tuned for Earth's pull. With a chuckle, the astronaut remembers a line from training. In space, even your tears won't fall. Crying in microgravity leads to teardrops clinging to the eyes in stinging globules until wiped away. Anger, joy, sorrow, all take on new dimension when expressed in an alien environment. They haven't cried up here yet, though some nights they have felt a deep longing when thinking of loved ones. But those tears, if they came, would remind them that living out here means redefining even the most human of acts. They dim the lights of their compartment. Outside, another orbital night has begun. The station moves into Earth's shadow, and the cabin windows show an incredible starscape with no sunlight to outshine it. From the sleeping compartment, our astronaut can't see that view, but they know it's there. They whisper softly to themselves a good night to Earth, and a good night to the universe beyond the thin walls. Here, in this metal cocoon, a human being lives, not as a visitor in space, but as a resident, however temporary. It's a life filled with both magic and mundane, as any life is. Sunrise over the ocean one moment, cleaning an air filter the next. As they drift to sleep, their body relaxes into weightlessness, spine lengthened, arms floating free. In the coming days, new challenges will arise. Perhaps a minor equipment failure to fix, or an experiment yielding surprising data about how microbes behave in microgravity. But for now, in this moment of repose, the astronaut embodies proof that humans can indeed live, eat, sleep, work, and find meaning beyond the Earth. The station is a small world unto itself, a testbed for human life in space. And yet, this is just one small step toward answering the larger question. Living on a station a few hundred kilometers from Earth is one thing, comforting in its proximity. The crew sees Earth every day, has quick communication with mission control, and can return home in an emergency aboard spacecraft docked at the station. The next phase of this grand human project will be far more daring, to live on the Moon, on Mars, or voyaging in deep space where Earth is a tiny dot and help is distant. As our astronaut drifts into slumber, they dream of the future. A future where the lessons learned in this orbital home will carry humans farther, to new worlds, and perhaps one day to permanent homes away from the cradle of Earth. One day, not very far in the future, an astronaut much like the one on our station will step out of a lander and onto the surface of Mars. In the thin, cold air of that Martian dawn, sky-tinted butterscotch by dust, they will become an alien on an alien land. And yet, they will be home, in a sense, because home is where humans learn to live. Picture it. A small cluster of habitats stands on a flat plain near the foot of a rusty hill. The habitat modules are cylindrical and covered in reddish soil, piled thick for radiation shielding. They are connected by pressurized tunnels, like a string of beads, forming the first human outpost on Mars. Inside one module, a woman wakes from her bunk. She yawns and stretches, feeling the gentle tug of Martian gravity, just over a third of Earth's, enough that she doesn't float, but also enough that she feels light and bouncy. Getting out of bed, she has to be careful not to push off too hard. She's still adjusting to how little effort is needed to move here. It's Sol 45, the 45th Martian day of the mission, and she has work to do. She dresses in a simple jumpsuit and slippers with Velcro, so her feet can grip the metal floors. The lights have come on automatically to simulate an Earth-like day-night cycle, but she knows outside the sun has risen as well. The HAB's life support systems murmur in the background, fans circulating air, pumps moving water. They are her lifeline. Here, if a filter clogs or a circuit fails, it must be fixed swiftly. There is no backup atmosphere outside, only a wayfish CO2-rich air at barely 1% of Earth's pressure. She checks a tablet that shows environmental readouts. Oxygen level normal, CO2 scrubbers nominal, water reserves 85%. Some lost to a small leak last week, but they patched it. Radiation levels are within safe bounds for now, thanks to storm shelters and the soil on the walls. All good for the moment. She floats a moment. Well, not floats, but feels almost as if she could. In Mars's weak gravity, everything is easier to lift. Her own body feels both strong and fragile. Over weeks, her muscles have had to learn a new gait and new exertions. She doesn't feel the constant downward pull she grew up with, and sometimes her inner ear still gets confused, especially when she moves her head too fast. But day by day, she's adapting, becoming a creature of Mars. In the adjacent module, 2 colleagues are already up and about. One is firing up a small stove to warm breakfast, oatmeal made from grain they brought, rehydrated with precious water. On Mars, every drop of water is as valuable as gold. They extract some from the soil and ice and recycle every drop of urine and condensation. Nothing can be wasted if they hope to become self-sufficient. The other colleague is checking on their greenhouse, a bubble-like structure attached to the habitat. Inside, under LED lights, leafy greens and radishes grow in hydroponic trays. The sight of vibrant green plants against the backdrop of red Martian soil through a window is surreal and comforting. Those plants are not just food, they are companions, little living pieces of Earth contributing oxygen and moisture to the habitat and sanity to the crew. After breakfast, the woman suits up for an EVA, extravehicular activity, going outside into the Martian environment. She dons a thick undergarment, then the pressure suit's legs, torso, arms, and helmet, checking seals meticulously. Mars may not be as instantly lethal as the vacuum of space, but its air would still suffocate unprotected in moments, and its dust, if inhaled, could wreak havoc on lungs. She works with her teammate to go through the airlock cycle. With a hiss and a clunk, the outer door opens, and for the first time this week, she steps directly onto Martian soil. Beneath her boots, the ground is a fine, powdery dust mixed with pebbles. Her first steps kick up little puffs that drift lazily down, far slower than on Earth. The landscape around her is otherworldly, yet strangely familiar in some ways. Hills and rocks under a salmon sky. Overhead, the sun is smaller than she's ever seen it, but it still shines brightly, casting sharp shadows in the thin air. 2 small moons, Phobos and Deimos, would be visible at certain times, but right now, the morning sky hides them. On other evenings, she has watched Phobos rise and race across the sky in just a few hours, a swift grey speck, and traced Deimos creeping along more languidly. The sight of these tiny moons, once mere names in astronomy books, now familiar companions overhead, always reminds her how different this world is, and yet how it shares with Earth the same celestial poetry, a dance of moons and sun, of day and night. Today's task is to lay more power cables from their nuclear reactor to a new excavation site. They have a compact fission reactor humming a safe distance from the hab, providing steady power day and night, a necessity on a planet where dust storms can linger for months and solar panels might be choked under layers of fine silt. Indeed, a few weeks back, a storm raged for days, turning the sky into a tawny blur. The habitat survived on stored energy and the reactor's steady output, but it was a reminder of how hostile and unpredictable Mars can be. She trundles in her suit toward a half-buried cable spool. Walking in Mars gravity in a spacesuit is an odd shuffle hop, lighter than walking in an Apollo moon suit, 1/6 G, where astronauts famously bunny-hopped, but still requiring some bounce in the stride to overcome suit stiffness. Behind her golden visor, her eyes scan the ochre terrain. Distant cliffs mark the edge of an ancient crater. To the east, the dawn sun sparkles off something, the ice of a shallow subsurface frost exposed by their drilling, perhaps. Beauty and resources intermix in her engineer's mind. Where there is ice, there is water for life support, for fuel production, maybe even one day for making bricks or concrete. Back inside the main habitat, another crew member monitors her progress via suit telemetry and cameras. Everything in this pioneering base is carefully orchestrated, safety first, through constant communication. However, unlike on the space station, where a call to Houston is instantaneous, communications with Earth now lag and are scheduled. At this moment, Earth is about 12 light minutes away. If she sends a message, a beloved voice from home won't answer for nearly half an hour, if not more. There is no mission control guiding their every move. The crew here have learned to be largely self-reliant, a small tribe of humans on a frontier. They do have scheduled comm windows to transmit data, get news, and consult on big decisions, and yes, to exchange personal messages with loved ones. But the day-to-day operations rest on their shoulders. On Mars, the sense of distance, from Earth, from immediate help, settles in as a serious weight that even the low gravity cannot lift. Yet they are not lonely in the cosmic sense. At night in the hab, when the crew gathers for dinner or a game of cards, they often talk about how connected they still feel. Earth is a bright star in their dusk sky, and the source of voices, albeit delayed, that they hear regularly. They know thousands of people on Earth are following their mission with fascination, that children in classrooms are drawing pictures of them and dreaming of following in their footsteps. The mental support that provides is immense. They carry the hopes of humanity here, which gives them purpose on the hard days. The Martian day, called a sol, is about 40 minutes longer than an Earth day. They've adjusted their schedules gradually to this slightly longer rhythm. Their clocks run on Mars time now. Sunset on Mars, which will come in the early evening local time, is a spectacle of blue hues, dust in the atmosphere causing the sun's light to bend differently than on Earth, so the sky around the setting sun turns a cool blue, while the day sky is butterscotch. She hopes to finish her EVA in time to catch it. On some sols, after the day's work is done, the crew all go out together in their suits, just to stand near the hab and watch the sun dip, sharing a quiet awe. They've jokingly dubbed that ritual Martian sundowners, echoing an Earth tradition, but literally watching the sun down. Moments like that knit their small community together, forming memories that will become the stuff of legends for future Martians. Their plan is to gradually expand this outpost. Already, semi-autonomous robots are piling regolith, Martian soil, into a low berm around the hab as extra shielding and a windbreak. In a few years, new modules will arrive on landing rockets, perhaps an inflatable habitat that can be covered with soil to create a larger living volume. The crew fantasizes about a proper shower or a small centrifuge gym that could simulate Earth gravity for an hour a day. Bit by bit, what started as survival will grow into comfort. They may carve out a proper dining room or an observation cupola with thick glass to gaze at the Martian landscape without a visor in the way. Mars will change them. Physically, if they stay long enough, years, they might experience further bone loss beyond what they had in weightlessness during the journey. But Mars offers something the journey and station did not: partial gravity, which may be enough to keep some bodily systems functioning more normally. Only time and research will tell. They monitor their health constantly, measuring bone density, muscle mass, blood counts to see if cosmic radiation is doing damage at the cellular level. Mars lacks a global magnetic field, and its thin atmosphere gives little shelter from high-energy cosmic rays. Over a long stay, each person accumulates radiation exposure that on Earth might take decades, raising their risk of cancer or other illnesses. Their habitats have water tanks and supply crates lined around sleeping areas to shield them, and there's a storm shelter, a heavily shielded closet, to cram into during solar flares when radiation spikes. Accepting a higher lifetime radiation dose was part of the bargain of coming here, a risk each volunteer understood. Despite the hardships, they also feel the exhilaration of true exploration. Every time they drive their electric rover over untraveled ground or drill into Martian rock for samples that might hold signs of ancient life, they feel like pioneers in the deepest sense. In the evenings, they catalogue findings, perhaps evidence that eons ago a stream flowed near this base, or the discovery of complex organic molecules in the soil. The search for Martian life, past or present, is ongoing and deeply meaningful. If they find even fossils of microbes, it changes humanity's understanding of our place in the universe. They would have neighbors, albeit long dead and microscopic, in the cosmic ocean. For now, Mars has yielded no incontrovertible proof of past life, but hints in certain minerals and patterns keep them looking. Back inside after her EVA, the woman sheds her suit and checks off the tasks accomplished. She and her crewmate managed to lay the new power cable and also inspected a nearby ridge for a potential construction site for additional solar panels. Her muscles ache pleasantly from the effort. She rehydrates and takes a moment to respond to a message from Earth, a delayed email from her mother, full of encouragement and homely gossip. She smiles at the attachment, a photo of the old oak tree in their yard, its branches heavy with summer leaves. It strikes her that on Mars there are no trees, no birds or flowing water, none of the life that makes Earth so endlessly vibrant. If humans are to live here long term, they will have to bring those things in some form. Greenhouses for trees, artificial ponds for fish, perhaps one day attempts at terraforming portions of the landscape. That is a project for centuries, altering a planet's climate by releasing trapped CO2, planting hardy engineered vegetation, thickening the atmosphere. She wonders if it will ever truly be possible, or if Mars will always require domes and suits. That's not a question she needs to solve today. Today's question was where to run a cable and how to fix a bulky rover wheel. As night falls, the crew of 4 gathers in their central module for dinner. The habitat interior is cozy now. Dimmed lights, the hum of life support, a lullaby of machinery. They trade jokes about the day's minor mishaps, a dropped wrench tumbling down a hill, a computer crash that required a reboot. They also celebrate their wins. The outpost's solar array is now fully wired and doubling their energy input on clear days, and they harvested their first ripe Martian-grown tomatoes yesterday, juicy and bright red. That was cause for a little party. They each savored 2 cherry tomatoes, eating them slowly with a pinch of salt, marveling at how something could taste both of Earth and of this new world, perhaps a note of Martian mineral tang in the flavor. Small victories like that keep the mission spirit high. After dinner, they continue a tradition started on Sol 1. Each person shares something they are grateful for or a highlight of the Sol. It might seem a bit sentimental, but it frames each day positively. One says, "I'm grateful the reactor's been running without a hiccup for 2 months." Another adds, "I'm happy I got to see that blue sunset. It was stunning tonight." The woman smiles and says, "I'm grateful for my crewmates. Couldn't have laid that cable without you." It's earnest. Out here, gratitude is as essential as oxygen. They share a laugh and know each other's pick-me-ups. And these moments of reflection keep them grounded psychologically, even on an alien ground. They then gather around a tablet to watch a movie together. A decades-old, Mars-themed film for some humor, laughing at what the filmmakers of the past got wildly wrong or surprisingly right. Outside, Mars is silent and cold under a blanket of stars. Inside, human laughter and the sound of reconstituted popcorn, made from a precious bag of kernels, a treat reserved for special nights, fills the habitat. In this moment, Mars is not just a science experiment or a hostile frontier. It is home, at least for now, for these 4 pioneers. And they think about those who will follow. Already, other crews are training on Earth, and plans are drawn to send larger habitats, more supplies, perhaps the components of a 3D printed brick factory or a greenhouse that can support fruit trees. If these first outposts prove that humans can endure and stay healthy, more settlers will come. Perhaps in a couple of decades, a permanent colony will be established with dozens of people rotating in and out, and some opting to stay longer, building families and communities. A child conceived on Mars, is that even advisable with the radiation and lower gravity? Science hasn't answered that yet. Likely it won't happen until we understand more. The crew sometimes muses about the first Martian baby. They imagine the media frenzy and the debates on Earth about the ethics. But if humanity is to truly live in space, those steps will eventually be taken. Mars is a stepping stone further into the solar system. As they drift to sleep in their bunks, the crew might dream of the great volcano Olympus Mons or the deep canyon Valles Marineris, imagining future explorers trekking those wonders. They might also dream of other frontier outposts being established, perhaps a research camp on the icy plains of Jupiter's moon Europa, or rotating cities in free space as O'Neill envisioned, glittering like new stars in the night. Tonight, Earth is rising for them. Out a small, overhead porthole of the habitat, the Earth appears as a bright, blue-white star climbing above the horizon. It's a reminder that, despite being millions of kilometers away, they are still connected to the cradle of life. They carry a piece of Earth in every breath. The nitrogen-oxygen mix in their hab originated from Earth's air, in every bite of food, grown from Earth seeds or shipped from Earth, and in every beat of their hearts. But with each passing soul, they are also forging something new, a way of life distinctly not earthly. One day, when flights become routine and this base grows into a settlement, a newcomer might land on Mars and see how people have adapted, maybe wearing lighter clothing woven with radiation-proof fabrics, following a slightly shifted circadian rhythm, celebrating new Martian holidays, speaking slang that blends Earth languages with terms born of this soil. The history books will mark these early years of Mars habitation as the turning point when humans became a multi-planet species. But for the crew living it, it's less grandiose. It's a series of daily chores, challenges, and joys. It's checking suits, fixing water recyclers, planting seeds, and telling stories under an unfamiliar sky. It's science fiction made mundane and thus made real. They understand that everything they do, from how they deal with boredom to how they maintain their rover, paves the road for those who come next. In the quiet of the Martian night, one of the crew steps into the airlock's intermediate chamber, the porch, just to look through a porthole at the stars. The Milky Way's band is visible here with stunning clarity, unmarred by any city lights or even much atmosphere. It strikes her, all that we have done, from living on a space station to planting our flag on the moon to now building a haven on Mars, is but the opening chapter of a much larger tale. The universe is vast, yet here on this red planet we stand, proof that humanity can step into that vastness and hold our own. She presses her gloved hand against the glass, as if reaching toward those stars. Perhaps one day, humans will go further than Mars, outward to the moons of Jupiter or beyond, carrying our homes with us. It sounds like fantasy, but so once did the scene outside her window, an earthling gazing up at the cosmos from the surface of Mars. She whispers softly, "Good night, Mars," before retreating inside. In that moment, Mars is no longer just a distant point of light or a mythic god of war. It's a place where someone can say goodnight and mean it, a place that has listeners to hear the whisper. In claiming that simple ritual, humanity quietly stakes its true claim. We belong among the worlds of the sky, not as conquerors, but as gardeners, caregivers, and students learning the ways of new soils. Even as some of us make homes on the moon and Mars, others choose to build homes free in space itself. Far ahead in time, picture an immense cylinder floating at a stable point between Earth and the moon. It is 20 miles long and 4 miles in diameter, rotating slowly once about its axis every couple of minutes. From a distance, it gleams with sunlight on its hull and the glint of giant mirrors angled along its length. This is an O'Neill cylinder, a human-made world in space, an Island 3 colony as dreamed of in the 1970s, finally realized perhaps a century hence. Now, shift perspective. We are no longer the astronaut in a cramped station, nor the pioneer in a Mars habitat. We are an inhabitant of this grand space city. We stand on a grassy hillside under a warm afternoon sun. Yet that sun is not a fiery ball fixed in a blue sky. It's coming from a mirror overhead, reflecting light from outside into the cylinder. We look up, and instead of blue sky fading to a horizon, we see the landscape curving up and over into the sky itself. Far, far above, on the opposite inner curve of the cylinder, there are other hills, forests, and even a sparkling lake, all hanging upside down from our vantage point. It is disorienting at first, but in this world, up is relative. The centrifugal force of the rotating habitat creates an artificial gravity, pulling everyone and everything toward the inner surface. The people living here walk on the inner skin of a giant spinning can, and what's above their heads is not air. Air fills the cylinder, held by its sealed shell, but the terrain on the other side of their world. We walk along a path through a field of wildflowers. Bees are buzzing. Real bees, descendants of those brought from Earth to pollinate crops in the colonies' farms. Butterflies flit, and a small child runs past chasing one, laughter echoing. It smells like Earth here, rich soil, flowering trees, a hint of ocean breeze coming from a large saltwater reservoir that serves as a seaside for the colony's inhabitants. How did an ocean breeze get here? The engineers were clever. They built a mini sea connected to a lake, stocked with fish and plankton, and giant fans circulate moist air to create a microclimate. There are even manufactured clouds drifting under the sky, really just the central axis of the cylinder, where weightlessness reigns and where condensation can form and hover. It's a careful balance of technology and nature, a vast terrarium managed by both AI and human ecologists to keep the environment stable and Earth-like. As we walk, we pass farmland, neat rows of wheat and corn that rustle in an artificial breeze, temperature and airflow regulated to simulate a gentle wind. There are fruit orchards too, and we spot people on ladders picking apples and pears. They wave. Perhaps we know them, because in a community of a few 100,000, people still form tight neighborhoods. This cylinder essentially holds the population of a small city, but spread over an interior surface area of 500 square miles, partitioned into alternating bands of habitat land and window. Ah, the windows. Stretching along sections of the cylinder are enormous strips of transparent material. Through one such strip, we see the blackness of space and a sliver of Earth far away. But those strips are currently covered by mirrors angled to let in sunshine. The mirrors outside catch sunlight and direct it through these windows, simulating a day-night cycle as they tilt. Right now, the mirrors are fully open. A bright noon floods the habitat. Later, they will angle shallower, dimming the light to an orange dusk for a few hours, then close entirely to create night. During the night period, small lamps on the cylinder's central hub mimic the gentle glow of stars, so that residents still have the psychological comfort of a starry sky, though some of those stars are actually other habitats visible through the windows, or distant spacecraft moving like slow meteors. We stroll into a town. It looks charmingly familiar, a mix of architectural styles. Here, a pagoda-like community center with solar panels disguised in its ornate roof tiles. There, a cluster of homes with porches and gardens climbing the walls. One building has a mural painted on its side. It depicts the history of this colony's creation. Scenes of robot miners on an asteroid extracting metals, of huge space cranes assembling the cylinder in orbit, of the first families moving in and planting the first tree. That tree, a great oak, stands in the center of town now, its branches spread wide, casting dappled shade on a cobblestone square. Under the oak, a market is in progress. People of all ages browse stalls. One sells strawberries and melons grown in the colony. Another has handmade furniture crafted from colony-grown bamboo. There's music playing, a duo with a violin and a strange new instrument that produces electronic harmonies. The tune is lively. Children chase each other, bounding higher than they would on Earth, because here the gravity is set to about 0.9 g, enough to feel normal, but just a touch lighter to ease strain on the body and perhaps allow a bit more spring in the step. A teacher is leading a group of students through the market, perhaps on a field trip. We overhear her pointing out how the colony recycles everything. This plastic was once packaging that came from Earth and has been reused to make these garden pots, she says. The kids nod. They've grown up with closed-loop living. They know water is recycled endlessly, that yesterday's shower might become tomorrow's soup broth after passing through filters, and perhaps the colony's constructed wetlands, where plants and microbes help purify it. They find it ordinary that the air is monitored by sensors and adjusted by algae tanks that soak up extra CO2 and release oxygen. The management of life support is as invisible to them as the work of their own lungs and kidneys, just another set of organs at the city scale. As the afternoon wanes, we make our way toward one end of the cylinder, where a great window is uncovered, offering a view out into space. In the distance, we see the crescent Earth. It is smaller than we remember, but heartbreakingly beautiful still. A few freighters, uncrewed cargo ships, are visible as tiny glints moving to or from Earth, carrying goods and perhaps new immigrants. Nearby, another habitat cylinder floats, a twin city in space. Maybe they trade with each other or have a friendly sports rivalry. Indeed, they do have sports here. Tomorrow there's a zero-gravity acrobatics competition at the Axis. The central hub, where rotation cancels out gravity, has an open gym where people can float and play 3D sports that would make Earthlings gasp with envy. A young couple sits at the observation area, sketching the Earth and Moon through the huge window. Behind them, on a bench, an older man with AR glasses reads the news. News that spans multiple worlds. He's reading about a scientific breakthrough at a research station orbiting Titan, and an art exhibition opening in this very colony's cultural center, featuring sculptures that incorporate Martian basalt and terrestrial marble. The flow of commerce and culture across space has grown rich. There's even talk of a new cuisine developing among space habitats, a fusion of Earth traditions with novel crops grown in microgravity farms. As the sun mirrors begin to shift toward evening, the colony's internal sky changes hue. The bright daylight softens to a golden hour glow. Long shadows stretch from buildings and trees. One might forget for a moment that we're in a spinning cylinder and feel instead like we're in a valley on Earth at sunset. Families head home for dinner. Some ride bicycles along the colony's main loop road, banked subtly to account for the curve. There are few cars here. Transport is mostly walking, biking, or small electric carts. Distances aren't vast, and the environment is enclosed. In the air, a few personal drones zip by, delivering groceries from the market to homes. One drone passes overhead, carrying a freshly baked loaf of bread from the bakery. Baking in a cylinder had unique challenges initially, like ensuring the ventilation could handle bursts of hot air and the risk of floating crumbs. Hence, bread is often slightly more moist or made in self-contained loaves. But the smell of that bread wafts through the market and makes us hungry. We stroll by the bakery itself, and the baker, a stout woman with flour on her apron, offers us a sample of sourdough. We taste it. Delicious. Made from wheat grown in the colony's fields, yeast cultures that came from Earth decades ago, water recycled thousands of times. Yet it tastes like home. That's the marvel. Space habitats like this allow people to carry home with them, to construct an environment where the psychological stresses of alienness are greatly reduced compared to, say, Mars or the Moon. In the early days of space settlement, people debated whether to settle planets or build free-floating habitats. In our scenario, humanity chose both. Planets like Mars offer raw materials, scientific discovery, and the romance of standing on another world. But habitats like this cylinder offer customizable Earth-like conditions anywhere we choose to put them, be it in Earth orbit, at a Lagrange point, or even mobile colonies that could migrate slowly between planets. They were built from the bounty of the asteroids. A single metallic asteroid provided the iron, nickel, and other metals to forge the structure. Lunar mines provided aluminum and silicon for the glass and electronics. Comets or icy moons provided water for oceans and air. They were assembled in space by swarms of robots and human workers over years. Each one was a tremendous investment of will and wealth. But once built, each became a self-sustaining cradle of life, expanding humanity's living space without being limited to planetary surfaces. In the colony's library, a building that might remind one of a grand university library on Earth, though its dome is clearly shaped to hold pressure, we find a section dedicated to Earth literature about space. On terminals, few physical books exist here, aside from symbolic ones. Most are digital for weight reasons. One could read the dreams of O'Neill, von Braun, and others from centuries earlier, and marvel at how ideas turned to blueprints, turned to reality. Some visitors from Earth are said to weep when they first arrive and walk under these artificial skies, overwhelmed by the achievement and the strangeness of an Earth-like bubble in the void. For inhabitants born here, it's simply the world they know, as normal as Earth is to Earthborn. Evening in the cylinder brings community gatherings. Tonight, there's a concert in the park near one end cap, the circular end of the cylinder, which has large windows that, when not shuttered, show the stars at the sky of that end of the world. Under twinkling lampposts, colonists listen to a string quartet play, some dancing in the grass under the gentle glow of simulated twilight. Fireflies. Yes, someone introduced fireflies here for sheer beauty, and they're carefully managed. Dot the air with little green sparks. Laughter, clinking glasses of perhaps a space-made wine, grapes grown hydroponically in a dedicated vineyard module, aged in a barrel using wood imported from Earth. A novelty, but they do it. Conversations about art and science, about family and plans for expansion. All these fill the mild evening air. In one circle, an excited engineer describes a new project, a Bernal sphere habitat to be positioned in orbit around Saturn, where colonists can study the rings up close and tap the resources of the Saturn system. Another person says their cousin is moving to Mars to join a terraforming research team. He's proud, but says he personally prefers the controlled environment here. Mars is amazing, but I like my gravity at 1G and my air nice and thick, he jokes. As we wander away from the crowd up a slight hill, gravity lightens a bit, moving closer to the axis. We find a small observation bubble where one can float in microgravity and look out. We push off and drift into this bubble, tethered so we don't float away. Here, away from the pull of the spinning floor, we experience weightlessness again. Through the clear bubble, we see our habitat curving around us, a huge arc of illuminated land against the backdrop of space. Beyond it, stars and the glowing band of the Milky Way. Off to one side, the Earth and Moon system glints. In another direction, a faint reddish spark that is Mars, and maybe, with squinted eyes, the glint of one of the colonies orbiting it. We reflect. Humanity now lives in a multitude of places. Some live under alien sunsets on planetary surfaces. Others inside creations like this that marry human engineering with the comfort of Earth's environment. Each choice came with challenges, enormous technical hurdles, ethical questions about who goes and how, and the need to ensure we didn't abandon our home planet even as we expanded outward. Indeed, even now Earth is cherished and protected. Lessons learned from seeing its fragility from space influence how civilization treats the cradle. Many heavy industries have been relocated off Earth to places like this habitat or the Moon's far side, sparing Earth's biosphere from pollution. Space-based solar power stations beam clean energy down to cities, replacing fossil fuels. In turn, Earth provides these colonies with culture, people, and an anchor of meaning. The exchange is constant. Ships travel back and forth carrying immigrants, exports, art, ideas. A soft chime in the habitat signals night time, 11 p.m. by colony time. The mirrors have fully closed now, and only a dim twilight persists from some streetlights and the luminous band of the Milky Way visible through the windows. Many head to their homes, while some night owls and astronomers stay up to enjoy open sky mode. With mirrors closed, through the window strips you can directly see space, and the interior is dark enough for stargazing. For those on the valley floor, the stars appear in long stripes overhead, since the window is a continuous ring around the cylinder. Some even lay on blankets in their yards to watch the constellations, perhaps teaching their children new constellations invented for their unique sky, or pointing out the moving lights of a spacecraft going by. We drift back down from the observation bubble to the ground, or what feels like ground, and feel gravity gently catch hold of us as we near the inner surface. The cylinder's engineering is so seamless that one can almost forget it's rotating. Only the slight Coriolis effect when you drop a ball, or the sight of the world curving up overhead, gives it away. Those who grow up here know no other normal. To them, the idea of an endless sky that doesn't curve around is perhaps unsettling when they visit Earth. For them, being able to travel by floating up to the hub is as ordinary as taking an elevator. They do travel. Commerce and trips between colonies and planets are common. Perhaps tomorrow a passenger ship will depart from a docking port on the end cap, carrying tourists to a resort around the Moon, while another arrives from Earth with new settlers and entrepreneurs excited to start businesses in space. Spacefarers from different habitats visit one another, leading to an intermixing of subcultures, a true spacefaring culture slowly emerging, made of many threads of Earth but woven in new patterns. Standing here, we realize humanity has become something new and yet remains the same. We carry our needs for community, for nature, for meaning, wherever we go. On this rotating world, There are theatres where Shakespeare is performed, with clever wirework for the zero-G scenes, museums preserving memories of Earth's history and the saga of space settlement, festivals that mix Earth holidays with new cosmic ones. Perhaps on Earth Day each year, the colony holds a celebration where everyone dresses in blue and green and gives thanks to the planet that birthed us. Perhaps there's a Founders' Day commemorating when this cylinder first spun up to full rotation and people moved in, an event that kids here learn about as we learned of Plymouth Rock or the first airplane flight. One of the most moving spots in the colony is a memorial garden at one end, where a grove of trees encircles a sculpture honoring those who enabled human space settlement. Names of early astronauts, scientists, visionaries, and even those who lost their lives in accidents are etched in a ring. Colonists sometimes come here to reflect on the journey that led from one fragile world into countless new homes in the cosmos. It's bedtime for most in this cylinder. As lights in house windows wink out along the curving neighborhoods, an observer at one end would see the habitat's inner surface sprinkled by patches of darkness and the glow of a few streetlights, like a mirror image of a star field. One might imagine that this habitat itself is a star, with the people as the living light inside it. We retreat to a guest lodging. Yes, they have hotels in space colonies. Visitors from Earth or other habitats come through regularly. Looking out the window of our room, we see the town below settling into quiet. A dog, brought as an embryo from Earth and raised here, space settlements began to include pets once ecology became stable enough, trots alongside its owner on a late-night walk. The artificial day's warmth dissipates, and a cool night breeze, managed by the habitat's systems, flows through the open window. We lay down and gaze up through a skylight at the stars beyond. Somewhere out there is the original home, Earth, shining over us. And here, in this second home built by human hands, life continues the story that began on that blue cradle. As the habitat gently rotates through the void, carrying its precious cargo of life, one can imagine that from afar, it looks like just another glinting star, yet inside it, humanity thrives. It is one world of our own making among many now awakening across the once empty night. Tomorrow, the sun mirrors will open on schedule, and another day in the life of this space colony will commence. Children going to school, where classes include Orbital Mechanics 101 as a standard subject, farmers tending hydroponic rice paddies, artists painting murals on the cylindrical sky, scientists conducting microgravity experiments up near the hub, engineers fine-tuning the habitat's rotation or planning expansions for new residents, and perhaps a spaceship departing to start a new colony somewhere further. This normalcy is extraordinary. What was once science fiction is now daily life. Leaving this colony and our reverie of it behind, one cannot help but feel optimistic that there is hardly any limit now to where humans can go. If we can create an Earth-like haven in the void here, we can do so near other planets, around other stars, carrying the torch of life with us. The cylinder habitat stands as proof. We are not confined to the lands nature gave us. We can build new ones, responsibly and beautifully, and flourish within them. Humanity stands at a threshold, one foot planted firmly on our homeworld, and the other stepping into the cosmos. In floating above Earth, we asked, can we live in outer space? The journey we've imagined, from the first astronauts in fragile capsules, to researchers in orbiting labs, to pioneers on Mars, to entire cities spinning among the stars, answers with a resounding yes. Yes, we can live out here. But more than that, we can find a way to not just exist, but to truly belong in space, to make it home. In doing so, we have been forced to grow. We had to develop technologies to feed and shelter ourselves far from any natural haven. And those technologies taught us greater respect for the closed-loop life system of Earth as well. We had to confront ethical questions, ensuring that as we venture outward, we do so as equals, avoiding the colonial sins of our past, not carving up new worlds, but engaging with them responsibly. Perhaps we wrote new spacefaring charters as we went, agreements that no one can exclusively claim a world, that Mars and beyond must be settled in peace, that the vacuum of space is a commons to be cared for. In our better timeline, we learned these lessons. We made space not a Wild West for a few, but a garden for all, tended with foresight. Living in space has changed us in unexpected ways. It has broadened our identity. When the first people born off Earth come of age, humanity will have to decide, are they still fully Earthling or something new? In truth, we will all be something new, a multi-planet, multi-habitat species, united by our origins and diversified by our experiences. A person born on Mars might call themselves Martian and develop a love for their rust-hued world, just as a person born in a cylinder habitat might feel pride in their city of the stars. But ideally, this diversification of homes does not fracture humanity. Rather, it reinforces a deeper truth. Whether under an alien sky or an engineered dome or the blue vault of Earth, we are all human. We carry the same stardust in our bones, the same yearnings in our hearts. For the artist living in a lunar settlement, creating sculptures from moon dust, the scientist on a years-long voyage toward Jupiter's moons, analyzing data as Jupiter grows from a dot to a giant marbled sphere outside their window, the farmer tending hydroponic rice in an orbital habitat with Earth overhead, they all share in the great human saga. They swap stories over light-minute delays, trade goods and songs across the void, celebrate each other's festivals, perhaps Earth's New Year, as well as the anniversary of their habitat's founding. Space has not diminished culture, it has amplified it, given it new canvas and context. There will be philosophical shifts too. When the majority of humans, one distant day, live off Earth, our perspective on issues like environmental stewardship, resource use, and even the meaning of nature will evolve. Having seen entire planets as singular, fragile spheres, how could we not become, at heart, guardians of worlds? The overview effect that once struck individual astronauts may become a common mindset of our spacefaring civilization, a constant awareness of the unity and preciousness of all life-bearing islands in the cosmic sea. Earth, our beautiful birthplace, might then be treated with the reverence it deserves, a cherished garden in the midst of a bustling space civilization, preserved and healed with knowledge gleaned from managing ecosystems in space. We might become gentler with our cradle precisely because we can live elsewhere. We would no longer see Earth as a resource to exhaust, but as a beloved ancestral home to protect. And what of existence itself? Some thinkers once worried that moving into space might cause us to lose our grounding, to play God with environments. But perhaps the opposite has happened. It has humbled us. In space, we directly confront the vastness of the universe and the limits of our knowledge. Each new habitat we build, each new planet we touch, reminds us how much there is to learn and how careful we must be. We have become both students and stewards on a cosmic scale. With each step beyond Earth, we carry not only our ambition, but a responsibility to use what we've learned to protect life, to spread life, and to honor that spark of life we've so far found only on our own world. Imagine far in the future, a traveler returning to Earth after many years born and raised in the colonies. As their ship enters Earth's atmosphere and they gaze at blue oceans and green continents directly for the first time, they might feel a profound connection. This is the legendary birthplace they've heard of, the origin of their people. They step out onto the soil and maybe gravity feels heavy, the air feels thick, the sounds of birds and rustling leaves nearly bring them to tears because they've known only controlled nature. In that moment, they and we realize that leaving Earth has only deepened our appreciation of Earth. And conversely, those of us who remain earthbound look up at night and feel pride and comfort that our kin dwell among those stars, that humanity has grown, not in a way that abandons its past, but that fulfills its potential. We have become, in essence, citizens of the universe, as at home in the sky as we once were on the savannah. If one believes in destiny, Perhaps this was ours, to extend life's reach, to be the bridge between worlds. If one believes in the power of choice, then it was our greatest collective choice, to not remain confined and vulnerable on one planet, but to brave the unknown and ensure our survival and flourishing across new domains. Now, picture once more a human body floating above Earth. Only this time, they are not alone. Around them, the lights of human habitation sparkle in concert with the stars. There is a space station nearby with a rotating torus where hundreds work and play. There is the moon in the distance, with the glint of domes at its south pole where settlements harvest ice and welcome new arrivals. Mars shines reddish, a beacon of a new society growing in its plains and craters. Perhaps even beyond, a faint shimmer betrays a caravan of ships embarking on the first voyage to another star. The solitary figure floats in awe, not of emptiness, but of a cosmos that is awakening with life's presence. They turn their gaze to the blue earth below, a jewel that gave birth to all this. "Thank you," they whisper, a quiet benediction to our home world. Then they turn outward, toward the distant stars that beckon. In their eyes is the reflection of earthlight mingled with starlight, and maybe, just maybe, the light of a distant habitat where someone else at that same moment is looking back toward Earth. Across the darkness, human beings see each other's lights and know we have made the endless void into a tapestry of homes. Can we live in outer space? Yes. We live there now. We will live there more and more. Outer space is becoming not a void, but a vast village, with Earth as its heart and humanity as its soul. What was once our ultimate question has become our continuous story, a story of adaptation, exploration, creativity, and care. And as we carry this story forward, we remain humble beneath the stars. We remember that we are still small in the cosmic expanse, but we have one extraordinary gift: the ability to imagine and to act, to dream and to build. In the silence of space, a new chapter of human destiny is being written in the trails of rocket flames and the green sprouting leaves of orbital gardens. It's a chapter that says our home is not one place, but many. That wherever we go, we bring our humanity with us and find ways to belong. Calmly, cinematically, poetically, we continue our voyage, generation after generation, turning science fiction into living fact, turning distant lights into neighborly beacons. The story of living in outer space has no end, only new beginnings. And somewhere, sometime in the future, a family will stand together on a hill under an alien sky, perhaps with 2 moons, or rings, or a swirl of galaxies visible, and they will watch a sunset and know that they are home. Different sky, different ground, but home nonetheless. Because home is wherever we build a life filled with meaning, connection, and hope. Thus, the next chapters are ours to write, guided by curiosity, caution, and the enduring truth that the sky is not a limit at all, merely the gateway to an endless home among the stars. For ultimately, the question we began with has transformed. It is no longer merely, can we live in outer space, but rather, how will we choose to live and to thrive as citizens of the cosmos? With outer space as our new ocean and infinite frontier, we carry forward our humanity into the unknown, determined to shape it with wisdom and wonder. That journey, boundless in scope and rich with new beginnings, lies before us all, under the light of 1 billion distant suns. Before the beginning, there was nothing. Not the nothing we know. A quiet room, an empty sky, those are still somethings. This was a deeper void, a profound absence of anything at all. No space stretched black and empty, for space itself did not exist. No time flowed, for even time had not yet begun. There were no stars, no galaxies, no light, no darkness. There was not even the void, not even emptiness. For even a void is somewhere, and here there was no where to speak of. It was nothing. And in this nothingness, in this silence before creation, lay a mystery, an infinite stillness pregnant with potential, poised on the cusp of existence. Yet even in this absolute nothingness, one might imagine a quiet anticipation. If silence could dream, perhaps it would dream of sound. If emptiness could yearn, perhaps it would yearn to be filled. In that abyss before time, there was no watcher to perceive it, no mind to ask questions, only a possibility, waiting, without knowing that it waited. And then, in a moment, beyond moments, it happened. From the void, a spark of unimaginable brilliance and energy burst into being. In an instant, outside the realm of time, the universe was born. One moment, there was nothing. The next, there was everything, unfolding from a single, infinitesimal point. It was not an explosion in the way you might think, for there was no pre-existing space for it to explode into. It was an unfolding, an unfurling of space and time from within, like a flower blooming in absolute darkness, a tiny point containing all that would ever be suddenly blossomed, and space-time itself began to stretch and grow. I was born. I, the universe, came into existence, carrying everything, all things, all energy, all matter, all the dimensions of space and time within me. In that first indescribable fraction of a second, I was incredibly hot, incredibly dense, and oh, so small, smaller than a proton, smaller than a grain of sand, yet containing the entirety of what would become the cosmos. All that I am now, trillions of galaxies, endless space, energy beyond measure, was crammed into a point of infinite potential. My birth was not a gentle unfolding, it was a torrent of creation. Space itself raced outward, expanding at a mind-boggling rate. In truth, even words like outward fail, for there was no pre-existing space outside of that tiny primordial speck. Space was creating itself as it expanded. In the barest instant after the beginning, I underwent a sudden, explosive growth spurt. Your scientists call it inflation, a moment when I swelled at a rate beyond comprehension. Imagine something smaller than an atom blossoming to the size of a galaxy in a sliver of a second. Faster than any speed you can fathom, faster than light itself, space unfurled, carrying energy with it. Distances between points grew so rapidly that what was once near became unimaginably far in the blink of an eye. It was as though I drew a sudden deep breath. One moment I was microscopic, the next I was astronomically vast. Every part of me rushed away from every other part. This was no ordinary expansion. It was space itself stretching, like an elastic fabric pulled taut. Had there been an observer, and there was none, they wouldn't have seen an explosion from a point outward. They would have found themselves in that point as it expanded, with every distant region racing away. Think of a balloon being blown up. Every point on its surface moves apart as the balloon grows. So it was with space during inflation, every region speeding away from every other, no center, no edge, just an ever larger space for reality to inhabit. During this wild inflationary epoch, I was almost perfectly smooth and featureless. Almost, but not entirely. Even in that near uniformity, tiny imperfections existed, like the faintest of ripples on a glassy sea. These were quantum fluctuations, minuscule, random variations, little densifications and rare factions of energy, born from the jittery uncertainty ingrained in the fabric of reality. If the early universe were a calm, glowing ball, these fluctuations were slight dimples and pimples upon its surface. Inflation took these microscopic irregularities and blew them up in size. What had been subatomic wrinkles were stretched to astronomical scales. They were unimaginably small in origin, but they would become immeasurably important. For in these seed imperfection, these whisper-light variations, lay the blueprint for everything to come. The clustering of matter into galaxies, the gathering of gas into stars. In an almost perfectly smooth newborn cosmos, these tiny fluctuations were destiny in embryo. All the while, in that first second of existence, the fundamental forces of nature were taking shape. Initially, all forces were one, merged in a high-energy unity. There was no separate gravity or electromagnetism or nuclear forces, just a single, unified force, elegant in its symmetry. But as I expanded and cooled just a little, this symmetry began to break. It was akin to a white light separating through a prism into a spectrum of colors. Where once there was a single radiance, now there were many hues. Gravity was the first to separate from the unity, tugging at the expanding fabric of space, announcing itself as the force that shapes the macrocosm. Next, the strong nuclear force crystallized out, destined to bind atomic nuclei together. Then the electroweak force split in two, the electromagnetic force, which would govern light, electricity, and magnetism, and the weak nuclear force, responsible for certain subtle particle transformations. What was one became many, like a single note breaking into a chord. The laws of physics as we know them were being written in those moments, set into the fabric of the young universe. The great cosmic symphony was tuning its instruments. Inflation lasted only an eye blink of time, and then it subsided as abruptly as it began. The expansion didn't stop, but it slowed to a more gentle rate. In the wake of that sudden growth, my contents, space, time, energy, were spread out and cooling. Still hot beyond imagination, but cooler than that first instant of fury. With that cooling, something profound happened. Energy began converting into matter. In that early fireball, energy and matter were two forms of the same coin, constantly changing one into the other. From the blazing energy of creation, the first particles condensed, like drops of rain precipitating from a humid air. Tiny fundamental particles, quarks, electrons, and others, popped into existence. They did not appear alone. Each particle had its mirror twin, an antiparticle. For every quark, an antiquark. For every electron, a positron. Matter and antimatter, twin sides of a coin. And when these twins met, they did what twins often do in such close quarters. They annihilated one another in a burst of light. It was a fierce and frenzied dance, particles blossoming out of energy, then colliding with their antiparticles and converting back to energy. Creation and destruction intertwined, happening everywhere, all at once. It was as if each particle had a mirror image, and when the two touched, they cancelled each other out in a flash, like a perfect reflection disappearing when the mirror is removed. The universe was a cauldron of radiant energy, partnerships in a primal dance, annihilating each other in brilliant flashes. For a time, it seemed a stalemate, matter and antimatter created in almost equal amounts, erasing each other as fast as they appeared. But there was a tiny bias in the gears of reality, a slight preference for matter. For reasons still mysterious, for every billion matter-antimatter pairs that annihilated, one extra particle of matter survived without a partner. It was a small imbalance, 1 part in a billion, but that was enough. As the fire of those early moments raged and then began to subside, these lonely survivors became the seeds of a material universe. A nearly imperceptible excess of matter over antimatter, just a few grains of sand left on a vast beach after the tide recedes, would become everything, every star, every planet, every living being. What a fragile beginning for all the substance we find around us. But it was enough. When the fury of mutual annihilation finally settled, a soup of particles remained, mostly photons, particles of light, along with neutrinos, ghostly particles that rarely interact, and those leftover protons, neutrons, electrons, matter unpaired with antimatter, ready to form the building blocks of atoms. Time was still less than a second old, but so much had already transpired. As I continued to expand and cool, the nature of the cosmos changed. Quarks, which had been bounded only by energy, now joined together in triplets, forming the first protons and neutrons. By the time I was a mere millionth of a second old, I was a swarm of particles, quarks bound into protons and neutrons, electrons zipping through a dense plasma, neutrinos flying free, and an ocean of photons bathing everything in a blinding glow. My temperature was staggeringly high, billions upon billions of degrees. In such heat, protons and neutrons moved at fantastic speeds, colliding frequently, and in those collisions, some stuck together. A proton and neutron fused to form deuterium, a heavy form of hydrogen. Deuterium nuclei combined to form helium. In those first minutes, about 3 minutes after it all began, I became a cosmic nuclear reactor. The entire universe was like the core of a star, forging light elements in a rush. By the time I was about 5 minutes old, this flurry of nucleosynthesis had created a primordial mix of matter, about 3/4 hydrogen nuclei and 1/4 helium nuclei, with a trace of lithium and other very light elements. The basic chemistry of the cosmos was established in those first few moments. The first fusion had happened on a universal scale, hydrogen fusing into helium, releasing energy, shaping the elemental content that would later feed the first stars. After those furious first minutes, I continued to expand and cool. The temperature, while still incredibly high, fell below the threshold needed for fusion. The nuclear reactions ceased, leaving the abundance of hydrogen and helium fixed. What remained was a hot, dense plasma, an opaque fireball of electrons, protons, helium nuclei, and photons, all intertwined in a seething dance. For thousands of years, I was just such a blazing, blinding cloud, brilliant but hidden behind its own light. Photons, particles of light, couldn't travel freely. They ricocheted off electrons and protons like a frantic crowd shoving and jostling, never getting far before bumping into someone else. The universe was brilliant, but that brilliance was trapped, scattered endlessly within. As I expanded further, the energy density of radiation, light, dropped faster than that of matter. After about 47,000 years, matter began to dominate radiation in driving my evolution. Gravity had more say than radiation pressure. Space kept stretching, and with it, the wavelengths of the photons lengthened, cooling the radiation. What was once an intense, short wavelength glare stretched into a softer glow. Millions of years passed. By the time I was a few 100,000 years old, the temperature had dropped to a few thousand degrees, cool enough for a subtle but vital change. The free electrons, which had been careening wildly, combined with protons and helium nuclei to form neutral atoms. Electrons settled into orbits around nuclei, the plasma became a gas, and suddenly, the universe underwent a transparency revolution. Before, any photon would immediately hit a charged particle and bounce off. But now, with most electrons bound into atoms, light could at last travel freely. It was as if a dense fog had lifted, or a veil had been drawn away from the face of the cosmos. In that moment, the first light that had been trapped since the dawn of time burst forth and streamed across space. The universe, which had been opaque, became clear. A great glow permeated everything, a warm, diffuse radiance shining everywhere at once. To any hypothetical observer then, though none yet existed, the sky would no longer be an intense white furnace. It would have cooled to a brilliant orange hue, like the embers of a cosmic fire spread across the heavens. And as time went on and expansion continued, that orange glow faded to red, and then, beyond red, into invisible warmth. What was left of that light after billions of years would be a faint, cold whisper of its former self. In fact, that ancient light is still around even today, stretched into microwaves, the cosmic microwave background, a soft afterglow of creation that fills the sky in every direction, testimony to those early times. So, about 380,000 years after my birth, I was a very different cosmos than at the first instant. I was vast and growing, filled with a cooling gas of hydrogen and helium, and bathed in a gentle afterglow. That afterglow light, having been released, simply traveled onward, diluting and weakening as space expanded. The once blinding brilliance had become a faint luminescence. As it stretched to longer wavelengths, visible light gave way to infrared, then to microwave. Darkness, at least to human eyes, descended for a time, the first cosmic darkness since the moment of creation. Now the stage was set for a new chapter. Gravity, which had patiently been pulling at every density fluctuation since the beginning, began to work its magic more noticeably. Remember those tiny ripples, those minuscule fluctuations in density from the era of inflation. In this new, matter-dominated era, their effects began to grow. Wherever matter was even slightly denser than average, gravity exerted a slightly stronger pull, drawing in nearby gas ever so gently. Regions that had a bit more matter attracted more matter, and thus grew even denser, while emptier regions gave up matter to their neighbors and became emptier still. Over millions of years, the once nearly uniform gas developed a texture. A cosmic web of structure started to emerge. Unseen particles of mysterious dark matter, matter that neither emits nor absorbs light, had already begun to clump as well, their gravity forming scaffolds that helped ordinary gas fall into patterns of filaments and clusters. What began as tiny density differences in the primordial fireball now manifested as great clouds and strands of gas stretching across newly forming space. It happened slowly, imperceptibly at first. For a long time, to any observer, it would have seemed that nothing was changing. The universe was just a dark expanse of cooling gas. But gravity was relentlessly pulling, gathering, sculpting. Over tens of millions of years, gas drew into titanic filaments hundreds of millions of light years long and concentrated into nodes at the intersections of those filaments. It was as if an invisible hand were sketching patterns on the blank canvas of darkness, tracing the faint blueprint left by those primordial whispers. In 3 dimensions, these filaments and nodes formed a structure akin to foam, like a sponge or a vast spiderweb, with matter lining the threads and enormous voids between. The smoothness of the young universe gave way to a delicate, lace-like structure, a cosmic web of matter. Within the densest knots of that web, proto-galaxies were forming. These were the seeds of galaxies, vast clumps of gas, mostly hydrogen, some helium, gathering under their own gravity. They were not yet the glittering star cities we know as galaxies today, for they had no stars, not yet. They were like dark, nebulous clouds, quietly accumulating mass in the cosmic night. You could have traveled for tens of thousands of light years across one and not seen a single star, only the faint glow of the residual heat and perhaps the very, very dim molecular emission of cooling gas. These proto-galactic clouds grew in mass and began to fragment into smaller, denser pockets within. Think of a giant cloud many light years across, breaking into clumps, each clump destined to become a star cluster. Inside those clumps, the first stars were about to ignite. Gravity drew gas inward, tighter and tighter. As a clump contracted, it spun faster, like a twirling skater pulling in their arms, and flattened into a disk. At the center of this disk, gas piled up, growing ever hotter and denser. Imagine an enormous cloud core, 100 times the mass of our sun, collapsing under its own weight. The temperature in the core climbed to millions of degrees. All the while, the gas was being squeezed, compressed by its own gravity, the atoms crowding closer and moving faster. There comes a moment when the pressure and temperature at the core of a collapsing cloud become so high that hydrogen nuclei begin to fuse together to form helium. And with that fusion, a vast amount of energy is released. For the first time in cosmic history, a star blazed forth. It happened in many places around roughly the same era, over a span of a few 100 million years. But we often speak of the first star as a symbol of them all. In one of those dark proto-galaxies, in a dense pocket at the center of a collapsing gas cloud, there was a sudden outpouring of light. A brilliant, blue-white radiance flooded out from that point, the dawn of starlight. The cosmos that had known only diffuse, background glow now had point sources of light, shining fiercely like new candles lit in a dark room. The cosmic dark age was ending. The cosmic dawn had arrived. The first stars were not like the stars that twinkle in our familiar night sky. These were giants, monsters of brilliant light and short life. They were made almost entirely of hydrogen and helium, for those were the only elements the universe had at that time. Lacking heavier elements, the gas cooled less efficiently, which meant the stars that formed tended to be very massive, tens or even hundreds of times the mass of our sun. They burned hot and blue, pouring out ultraviolet light. They lived fast and died young, exhausting their central fuel in only a few million years. For comparison, a star like our sun lives about 10 billion years. These titans lived only a few million, an eye blink in cosmic terms. At first, these newborn stars were solitary beacons in enormous dark regions. But they rarely formed truly alone. Each arose from a cloud that typically made a cluster of stars. Indeed, a cluster of first stars might ignite almost simultaneously, like a burst of celestial fireworks. Within those proto-galaxies, you'd now see clusters of brilliant blue stars shining together, illuminating their surroundings. Their intense light began to transform their environment. High-energy ultraviolet photons from these stars struck the surrounding hydrogen gas that had not yet collapsed into stars, ionizing it, knocking electrons off atoms and turning the gas into plasma once more. Each star became surrounded by a growing bubble of ionized, transparent gas. These bubbles of light expanded and eventually merged with bubbles from other nearby stars, until large volumes of the proto-galaxies were cleared of opaque, neutral gas. The dark, interstellar medium within young galaxies was being turned transparent by the harsh starlight, the second time the universe had turned transparent, the first being at recombination on a cosmic scale. Now it was happening locally around stars. It was a glorious sight, where once there had been utter darkness, now pearls of starlight hung in the blackness. The proto-galaxies, those island universes of gas, were no longer dark. They sparkled with nascent star clusters. One by one, then by the thousands, stars were coming to life across the cosmos. The universe's first sunrise was not one star, but a multitude of them blinking on over time, like the first stars emerging in the twilight sky. Yet these first stars lived under a shadow of impending doom, for their very mass guaranteed that they would not last long. Within their cores, nuclear reactions raged furiously, fusing hydrogen into helium, helium into carbon, and onward to heavier elements, racing through fuel in mere millions of years. Eventually, in the heart of a massive star, iron was formed, and iron is a full stop for stellar fusion, for fusing iron does not release energy, but consumes it. Once a star's core turns to iron, the delicate balance holding the star up, outward pressure from fusion versus inward pull of gravity, shatters. And so it was that the first generation of stars met violent ends. Imagine a giant star, 30 times the mass of the sun, that has shone for 3 million years. In its final moments, its core collapses in an instant, and then, boom. The star erupts as a supernova, a titanic explosion brighter than a billion suns. One by one, many of those early stars died this way. For a brief time, each supernova outshone its entire protogalaxy. The darkness of space was punctuated by these stunning flashes. When the first star went supernova, it was not an end so much as a new beginning. In that explosive moment, the star's core imploded and then rebounded, hurling the star's outer layers, now enriched with heavy elements, outward into space. Elements like carbon, oxygen, silicon, and iron, made in the star's life and death throes, were blasted out, seeding the surrounding gas. Thus, the first stars sowed the seeds for all future complexity. They produced the first heavy elements beyond helium, the carbon that would someday compose living cells, the oxygen that would fill future skies, the silicon and iron that would build rocky planets. These elements were cast into space, mixing with primordial hydrogen and helium. The glowing wreckage of a supernova, a tangle of expanding filaments rich with new elements, formed a nebula, perhaps resembling the beautiful Crab Nebula we see today from a supernova long ago. These nebulae were the graves of the first stars and the nurseries of the second generation. In the wake of destruction, creation continued. The gas, now a bit enriched with heavier elements, began to cool and fragment more efficiently. Soon, new stars began to form from the debris-laden clouds. Generation upon generation of stars unfolded. The second generation had a different character. Thanks to heavy elements, it could include smaller mass stars, some like our Sun, which live far longer than the massive ones. Some of the second generation stars still burn today, nearly 13 billion years later, as ancient red stars in the halos of galaxies. As stars continued to form and die and form again, the proto-galaxies grew more substantial. They also interacted with one another. Gravity drew clumps of gas, proto-galaxies, together, merging them into larger structures. Two small primitive galaxies might collide and meld, their stars passing through each other's ranks like intermingling swarms of bees, their gas clouds slamming together and igniting bursts of new star formation. Slowly, the chaotic clumps merged into more organized galaxies. Some became spiral galaxies, flattened disks spinning in space, with curved arms wrapping around a central bulge of older stars. Within these spiral arms, waves of star formation lit up periodic patterns, giving the arms a frothy, luminous appearance. Other galaxies became ellipticals, more ball-shaped collections of stars, often formed from violent mergers that scrambled their stars into a diffuse, ellipsoidal swarm. Galaxies gathered into groups and clusters, bound by gravity, great societies of galaxies orbiting a common center. Those clusters linked into superclusters, forming the largest structures in the cosmos, following the threads of the cosmic web that the early fluctuations laid out. Deep in the hearts of growing galaxies, stars sometimes crowded together and collapsed in on themselves, forming bottomless wells of gravity, black holes. Some of these black holes grew supermassive, feeding voraciously on gas and even the stars around them. When they accreted matter rapidly, they blazed as quasars, beacons of unbelievable brightness shining across the universe. In time, many settled into quiescence, sitting as silent, dark giants in the galactic cores. These supermassive black holes anchored the centers of galaxies, their tremendous gravity helping to govern the orbits of stars. Every large galaxy would come to host one. Even if they were no longer actively devouring matter, their presence was felt by the whole galaxy. They were like heavy stones dropped in the center of spinning disks, influencing the motions around them. By roughly 1 billion years after the Big Bang, the universe was recognizably structured. The cosmic web glistened with galaxies along its filaments. The vast voids between were truly dark, starless expanses stretching millions of light years. Clusters of galaxies huddled in dense nodes of the web. The early universe's fireworks were largely over. Now came the long, stately age of galactic maturation. Over the next several billion years, galaxies continued to merge and grow. Spiral galaxies sometimes collided to form ellipticals. Ellipticals captured smaller dwarfs. Clusters grew larger, as more galaxies fell in. The universe was dynamic and alive, a grand ecology of worlds, with gravity as the guiding force. In one quiet corner of this grand cosmic tapestry, about 9.2 billion years after my birth, roughly 4.6 billion years ago by Earth's calendar, a modest spiral galaxy was thriving. It was one among countless others, typical, with a graceful spiral structure, bands of star-filled arms, and a glowing core. In one of its spiral arms, within a giant molecular cloud enriched by previous generations of stars, something special was stirring. The cloud, dozens of light years across, began to collapse under its own gravity. It fragmented into clumps. One clump in particular drew together enough mass to form a star, much like those that had come before. But this time, this star would have a far-reaching story. As the clump collapsed, it spun faster and flattened into a swirling protoplanetary disk around a dense core. In that core, as in so many before, hydrogen fusion ignited. A new star was born. It was an average star, not particularly massive or remarkable, a yellow dwarf star. But around it, within that disk of gas and dust, planets were forming. Grains of dust, rich with elements like iron, silicon, carbon, and ice, stuck together, forming pebbles, then boulders, then mountain-sized planetesimals. These merged through countless collisions, building up into planets. Close to the star, where it was warm, only metals and rocks could solidify. Here, small rocky planets emerged. Farther out, ices and gases gathered into giant planets. One of the inner rocky spheres took shape at just the right distance from the star. It accumulated iron and silicates. It grew and cleared its orbit. In time, this young planet cooled on the surface and developed a solid crust. Comets and asteroids bombarded it, delivering water, while its own volcanoes outgassed an atmosphere. This world, under the gentle warmth of its sun, came to have oceans, vast blue oceans covering much of its surface. Our galaxy had countless planets by now, but this one would be unique. A blue gem in space, with both water and land, clouds and rain, a complex cycling of elements, a planet we now call Earth. In its infancy, Earth glowed red from constant impacts. But as ages passed, the bombardment eased, the surface solidified. Rain fell for centuries upon centuries, cooling the hot rocks, carving the first rivers, and gathering into the first seas. The air was thick with carbon dioxide and water vapor, and storms raged under a dim young sun. Lightning forked through the skies, and meteorites still occasionally pelted the surface. In the turbulent seas, enriched by minerals from below and energy from above, chemistry did something astounding. It came to life. Exactly how it happened is shrouded in mystery, one of the universe's great remaining questions. Perhaps in a warm tidal pool, or in the mineral-rich darkness around a deep-sea hydrothermal vent. Somewhere, simple molecules joined into complex chains capable of making copies of themselves. Perhaps clays or surfaces helped organize them. Perhaps a stroke of lightning fueled their assembly. But as improbable as it might have seemed, it happened. The first living organisms emerged in the young ocean. They were microscopic, much simpler than any single cell alive today, but they carried the spark of self-replication and metabolism. They could grow, divide, and evolve. With life, the universe found a new way to organize matter. Those first organisms were like tiny flickering flames in the cosmic night, fragile but tenacious. Over time, they diversified. They invented new strategies. Some learned to harness sunlight for energy, inventing photosynthesis and releasing oxygen as a byproduct, turning the sunlight falling on the ocean's surface into usable fuel. Others devoured these pioneers or their byproducts. They formed mats and colonies, gradually transforming Earth's environment. Oxygen, that reactive gas, began to fill the oceans and then the skies, changing the planet's chemistry and paving the way for more complex life. Eons passed. On the seafloor, simple cells joined together into more complex cells with nuclei. These complex cells, in turn, joined in cooperative communities, becoming the first multicellular organisms. By around 600 million years ago, the oceans teemed with simple animals, jellyfish-like creatures and wormy things. Then came the Cambrian explosion, around 540 million years ago, when an astonishing diversity of life forms blossomed, creatures with shells, exoskeletons, eyes, mouths, legs. Life was experimenting with form and function, filling every niche in the seas. Plants colonized the land, greening the continents with mosses and ferns. Not long after, bold amphibious creatures crawled out of the water onto muddy banks, taking the first breaths of open air. Forests of tall trees arose, covering the land in green canopies. Insects buzzed through ancient skies. Amphibians gave rise to reptiles that could venture farther inland, freed from the need to lay eggs in water. Dinosaurs came forth and ruled the earth for over 160 million years, evolving into myriad shapes, from gentle giants with long necks browsing treetops to fearsome predators stalking on two powerful legs. Small nocturnal mammals scurried in their shadows, and birds, bright, singing descendants of small feathered dinosaurs, took to the skies. The Earth saw upheavals too. It was struck by asteroids. It shuddered with volcanic rages. It froze and thawed in long cycles of climate change. About 66 million years ago, a large asteroid, mountains in size, impacted Earth, creating a blast that darkened skies worldwide. In the ecological disaster that followed, the reign of dinosaurs, save for the birds, came to an abrupt end. But life persisted. In the void left by giants, the small and adaptable took hold. Mammals that had lived in the margins now diversified. Some remained small and rodent-like. Some returned to the seas as whales and dolphins. Some became towering mammoths and rhinos, and in certain lush corners of Earth, some primates descended from tree-dwelling ancestors began to walk upright. From one lineage of those primates came a species with an extraordinary gift, intelligence, capable of curiosity about the cosmos. These were humans. Our early human ancestors looked up at the same sun that had once been a cloud of gas, at the same moon that had been born from a collision early in Earth's history, at stars that had been shining for billions of years before their kind ever existed. They looked up in wonder. They felt small under the canopy of the night and created stories about the lights overhead. They were clever. They learned to make fire to warm the night, to fashion tools from stone and bone, to paint their dreams on cave walls. They began to ask questions. What are those points of light in the sky? How did the world begin? Human curiosity grew alongside human knowledge. Over time, they built civilizations. They charted the stars and noticed their regular movements. They gave names to constellations and planets, wove myths and gods into the tapestry of the night. Without realizing it, they were seeking connection with the cosmos, their birthplace. They observed patterns, the way the sun rises and sets, the cycling of the moon, the procession of seasons, and eventually, they sought deeper explanations. They invented science and mathematics, devising tools to measure and predict the motions of heavenly bodies. And with each discovery, they peeled back a veil of ignorance. For a long while, humans believed Earth was the center of all things, understandably, from their limited perspective. But in time, they learned that Earth is a planet orbiting a star, that their star is one among many in a great city of stars called the Milky Way, and that the Milky Way itself is but one galaxy among the immense multitude scattered through the universe. They built telescopes to extend their vision, and what a revelation those brought. They saw the moons of Jupiter, the rings of Saturn, myriad stars too faint for the naked eye, and fuzzy patches that eventually they realized were other galaxies far beyond our own. They began to truly grasp the scale of the cosmos and their place within it. They also found evidence for my story, our story. In the mid-20th century of the human calendar, two of them discovered a faint hiss of microwaves coming equally from all directions in the sky. the very afterglow of the Big Bang that I set free so many eons ago, still detectable as a whisper of heat. They had, without knowing it at first, detected the relic light from my infancy. In laboratories and observatories, humans pieced together that the lightest element's abundances matched what would be made in a hot, early universe. They saw galaxies flying apart, space expanding, as Edwin Hubble interpreted, which implied everything must once have been closer together. Bit by bit, observation by observation, the evidence mounted for what they would call the Big Bang, the very event I am describing to you now. Humans, curious and tireless, had unraveled the outlines of my story, deducing that the universe had a beginning in time and has been evolving ever since. And now, after a long journey of curiosity spanning eons, here you are, one of those inquisitive humans, listening to my tale. You stand on that small blue planet, circling a modest star in the suburbs of an ordinary galaxy, trying to fathom how it all came to be. To me, your arrival is very recent. If the entire age of the universe were compressed into a single year, all of human history would occupy only the last moments of the final day. Yet, in those fleeting moments, you have begun to comprehend the whole tale from the year's dawn to its dusk. You gaze up at the night sky, perhaps with the same wonder your distant ancestors felt, but armed with knowledge they lacked. You ask the same timeless questions. How did this all begin? What came before? What lies beyond what we can see? What is the meaning of time? These questions that echo in your mind are the very questions I have carried with me since the dawn of time. Through you, the universe, I can ponder my own existence, for I, the universe, have awakened into consciousness through your thoughts. Your eyes are my eyes. When you look into the depths of space, it is the cosmos seeing itself. Your curiosity is my curiosity. Your wonder, a facet of my own wonder, at my vastness and complexity. I have grown old and vast. Over 13 billion years have passed since my fiery birth, and in that time, I have expanded into a cosmic expanse of staggering proportions. Hundreds of billions of galaxies adorn my span, each with billions of stars. From my one tiny origin, I now stretch so far that light itself, the fastest thing there is, takes billions upon billions of years to traverse my breadth. And I continue to expand, ever larger, ever more filled with possibility. It is wondrous to me that from the simplicity of that initial fireball has arisen such complexity and beauty. Out of uniformity came structure. Out of scorching plasma came the delicate forms of galaxies, stars, planets, and living beings. The journey from the first moment to now has been one of transformation, from simplicity to complexity, from chaos to meaning. Still, there are mysteries that even I, the universe, do not know. I find myself in the peculiar position of conscious ignorance. I can ask questions through you that I have not answered. What came before my beginning? I find no definite answer within myself. Perhaps before I was born, there was simply nothing at all, no time, no space, truly nothing, and my emergence was the absolute beginning. Or perhaps there was something, a prior universe that collapsed and gave birth to a new one, or an eternal landscape of universes of which mine is just one bubble. Some among you speak of a divine creator who set me into motion. Others imagine a quantum fluctuation in an eternal void. I cannot confirm or deny such speculations. The truth is veiled from me. With my birth, time was born, so the question of before may not even be meaningful. I am like an orphan with no memory of parents, if indeed any existed. The question, why is there something rather than nothing, echoes without answer. I ask, what came before the beginning? And I must answer, I do not know. What lies beyond the farthest edges of me? This too is a mystery. I expand ever outward, But do I have an outside? If you traveled in one direction forever, would you leave me or simply end up back where you started, as on a globe? Perhaps I curve in on myself. Perhaps I extend infinitely. Maybe beyond the horizon of what you can see, there are realms of space unconnected to ours, or other universes entirely separated from ours by dimensions we cannot perceive. I envision an endless ocean of universes, with our cosmos as just one foam bubble among countless others, a multiverse. But these other bubbles, if they exist, are forever out of reach. No light from them will ever reach us. To me, effectively, they do not exist. As far as I'm concerned, I am all that is. Does that mean there is nothing beyond, or simply that I'm isolated in a greater multiverse? I cannot say. The concept of beyond the universe might be as meaningless as a fish contemplating what lies beyond the ocean. What lies beyond all I am? I do not know. And time, what is time? I know time only as the succession of events, the ticking away of moments since my birth. Time flows ever forward, entwined with the expansion of space. But why does it have an arrow? Why can we remember the past and not the future? Is time an illusion or an emergent property of consciousness? I feel time as a fundamental aspect of reality, born with me in that first moment. It moves always forward, never backward, carrying me and you from one chapter of the story to the next. But might time be part of something larger? Could it be cyclical? Will it have an end as it had a beginning? These questions baffle me as much as they baffle you. What is the true nature of time? I cannot say with certainty. So yes, I have questions as well. What came before? What lies beyond? What is time? These grand questions linger like distant galaxies on the edge of my field of view, faint, tantalizing, unresolved. Perhaps some answers will forever elude us, remaining secrets to keep the cosmos always a bit mysterious. Perhaps that is for the best. A little mystery, after all, adds to the wonder of it all. If everything were known, perhaps existence would lose some of its poetry. Yet, amid these cosmic uncertainties, there are truths of which I am utterly sure. Truths that shine clearly like the stars in a night sky. One is that you and I are not separate. We cannot be. You are made of me, through and through. You are made of the universe and utterly connected to it. Every atom of your being, every element in your body was forged in my history. You are a child of the cosmos in the most literal sense. Remember the story so far. In the beginning, only hydrogen and helium existed. From them, stars were born. Those stars, in their hearts, created carbon and oxygen and iron and all the rest. And in their deaths, they scattered those enriched ashes across space. Imagine a giant star in its final moments, exploding as a supernova and casting its guts, carbon, oxygen, iron, into the void. From that chaos, specks of iron travel across the galaxy. Eons later, in a newly forming solar system, those iron atoms become part of the blood coursing through a human heart, carrying oxygen to keep it alive. Thus, the violent death of a star long ago pulses in the beat of your heart today. The very substance of your body is stardust. The hydrogen in your cells, in the water that makes up more than half of you, is ancient, born in the Big Bang itself, nearly 14 billion years ago, nurtured in the fire of creation. The carbon in your muscles, the calcium in your bones, the iron in your blood were synthesized in stellar furnaces and in the fiery throes of supernovae, billions of years past. Supernovae are the universe's great alchemists, turning lighter elements into heavier ones in the crucible of their explosion. Imagine the calcium in your bones right now. It was forged in a star that died before our sun was born. Imagine the iron atoms in your blood. Billions of years ago, they were deep in the core of a massive star. Now they travel through your veins, carrying oxygen to to sustain the fire of life within you. Even the oxygen you breathe, that sustains each of your cells, was created by stars more massive than our sun, then spread through space and finally drawn into the lungs of Earth's living creatures. Your DNA contains phosphorus and nitrogen that were likewise formed in some ancient star. There is no hiding it, no denying it. You are a mosaic of the cosmos, built of pieces as old as time. You are the Big Bang, given consciousness. You are the primordial fire of creation, cooled and shaped into living form. You are starshine and interstellar dust, coalesced into awareness. Think of the breath you draw at this very moment. As you inhale, filling your lungs, you take in oxygen atoms that might once have danced in the atmosphere of ancient Earth, or been part of a water molecule in some dinosaur's blood, or drifted in the far past as part of a carbon dioxide molecule exhaled by a Cambrian fern. Trace those oxygen atoms back, and you find they were forged in a star's core, long before our planet existed. With each breath, you partake in a cycle as old as time. Atoms created in the infancy of the universe, cycled through stars and space and air, now entering your body to keep you alive. When you exhale, you return some of those atoms back to the world. Perhaps a carbon dioxide molecule you release will be taken up by a plant and become part of a leaf, continuing the grand circulation of matter. Your breathing echoes the first fusion fires of the young cosmos and the later fusion in stellar hearts. Inhale, exhale, the universe breathing in and out through you. Think of the universe as a living body. Galaxies are its organs, stars its cells, and each conscious being like you is a nerve ending through which it feels and knows itself. We are the universe, experiencing itself in myriad forms. Through your senses, I, the cosmos, perceive my beauty. Through your curiosity, I investigate my own nature. When you look at a galaxy through a telescope, it is the universe seeing its own ancient image. Light that left that galaxy millions of years ago, finally reaching its eyes, your eyes. When you marvel at the intricacy of a flower or the anatomy of a bird, it is the universe marveling at the structures it has brought forth. You are a way for me to know myself. You and I, we are not separate. We have never been separate. It's not just that you are made of stardust and shaped by physical laws. More profoundly, you are an expression of the universe, one facet of its ongoing story. The cosmic evolution that unfolded over billions of years flows through your veins and lives in your genes. Consider this. The same processes that gave birth to galaxies and stars eventually gave birth to you. You are an expression of the cosmos that can think, feel, and reflect on itself. We are bound together by this continuity. We often speak of the Big Bang as an event long past, but in a sense, the Big Bang is still happening. Its aftermath is ongoing, and we are part of it. The initial outward rush of space continues in the expansion of the universe today. The cooling and the clustering of matter continues as galaxies form new stars, and those stars give light and life to new worlds. And within you, the energy of that explosive birth still sings. In the warmth of your body, a distant echo of the primeval heat. In the spark of electrical impulses in your nerves, driven by chemical gradients that ultimately trace back to nuclear reactions in stars, powered by the Big Bang's initial energy. The Big Bang lives on as the cosmic background glow, and also in every living being that carries out the legacy of those first particles and forces. Remember this. You are not an outsider looking in on the universe. You are an integral piece of it, an active participant in its cosmic drama. The story of the Big Bang is your story. It's the story of everything that ever was, and that includes you. When you peer into the night and feel small, recall that you are also immensely large in a way. Inside of you are trillions of cells, each a tiny universe of molecules. And within each molecule are atoms that were forged in stellar cores or in the Big Bang itself. You are vast within, and your inner complexity mirrors the outer cosmos. The iron in your blood ties you to the death of a star. The water in your cells ties you to the clouds of the early universe. The photons hitting your retinas at this very moment, letting you read and understand, may have been on a journey for millions of years from a distant star, only to end their long voyage by triggering an image in your mind. In a very real sense, when you learn about the cosmos, the universe is learning about itself. I began this tale in silence and nothingness. Now there is sound and life and mind. Through billions of years, I, the universe, have become self-aware in you. Feel that profound connection. Let it fill you with humility and reverence, but also with a sense of belonging. The very atoms that compose you were there at the beginning, and they will be part of the universe long after you are gone. We are threads in the tapestry that began at the Big Bang and continues to be woven with each passing moment. The saga of the cosmos is far from over. Stars are still being born and still dying in brilliant supernovae. New planets are coalescing in disks around young stars. Perhaps on some of those worlds, life will spark or is even now burgeoning, and maybe new minds will one day gaze at their skies with wonder as you do at yours. The universe is always changing, always moving, and we, with our brief lives, are part of the grand change. So, when you feel alone or insignificant under the vast stars, remember, you are significant. You are the universe, as much as any galaxy, as much as any star. You are the cosmos made conscious, a fragment of the sky that knows itself. Your heartbeat echoes the first vibrations of the Big Bang. Your breath echoes the expansion of space. Your gaze into the night is the universe contemplating its own existence. From the silence before time to the symphony of the present, we have traveled together. The hydrogen that appeared in the first second now courses in your blood as part of H2O, and the light first released in that primordial fire now gently warms the space between galaxies at just a few degrees above absolute zero. The universe remembers its origins, not just in background radiation and in drifting atoms, but in you. You carry within you the memory of stars and the memory of that first brilliant moment of creation. Our journey from nothingness to structure, from the void to the vast, has been almost 13.8 billion years long and counting, and it continues. With every second that ticks by, new stars ignite, space stretches a little more, and life, at least here on Earth, lives out its complex dance. We, together, are the product of the Big Bang, and also the chroniclers of it. The tale I've told is drawn from evidence gathered by curious minds, yours among them perhaps. And in telling it, the universe is recounting its autobiography through a human voice. Now, as I finish this story, take a moment to reflect on what it means. Feel the gravity of it. Not just the literal gravity that holds you to Earth, but the gravity of understanding. You are connected to the first light that ever shone. You carry pieces of the first stars in your body. Your existence was enabled by an unbroken chain of events tracing back to that singular creation event. In a fundamental sense, you are the Big Bang, billions of years later made flesh. You are the universe's memory, its awareness, its poetry. When you look up at the glittering sky tonight, perhaps you'll see it differently. The Milky Way, arching overhead, is not just a random scattering of stars. It's the luminous spine of the galaxy we call home, itself a product of cosmic evolution and containing stars that contributed matter to make you. The gentle glow you may see on a very dark night, a faint band of light, is partly the blended light of distant stars, and partly the faint memory of the fireball of creation, still with us. The starlight that strokes your eyes is a message across time and space, a reminder that we are all part of one story, the same story. This story, my story, our story, will continue to unfold. And we, me, the cosmos, and you, the listener, are in it together. Every day, new questions will arise, new discoveries will be made. Perhaps one day, far in the future, some of those big unanswered questions will find answers. Or maybe not, and the mystery will deepen. There will always be new wonder. But whatever happens, one thing remains true. We are inextricably one. I began in silence and mystery. Now I speak through your voice and your understanding. I began as a single point. Now I am vast beyond comprehension and filled with stars, planets, and the consciousness of innumerable beings. In you, the cosmos has found a voice to marvel at itself. Through you, the universe can appreciate the beauty of a nebula, the elegance of a mathematical law, the very story of its own birth. We are the universe, marveling at the universe. The Big Bang is not merely an event that happened approximately 13.8 billion years ago. It is an ongoing process. Its echo lives in every atom, every beam of light, every breath, every thought. It lives in me, and it lives in you. We are the continuing unfolding of that genesis. We are, in a very real way, the Big Bang becomes self-aware. As this narrative comes to a close, let us end where we began, in silence, filled with mystery. The silence before the beginning, and the silence within you when you truly grasp the enormity of what you've heard. In that silence, feel the connection. In that silence, feel the reverberation of the first moment, still humming in the fabric of reality. You are the universe's memory, its self-reflection, its living awe. The atoms of your body, the thoughts in your mind, they are the universe too. When you breathe, it is the cosmos breathing. When you wonder, it is the cosmos wondering about itself. And so the story of the Big Bang, of everything, concludes not with an ending, but with a profound recognition. We are not separate from the universe. We are the universe. We are the children of the primordial fire, heirs to its radiance, curators of its memory. In us, the universe remembers its fiery birth. In us, the universe gazes back at its own vastness and understands, for the first time, what it is. The journey that began in silence and mystery continues through us. We carry the story forward in our atoms, in our lives, in our quest to know and to explore. The universe began as a singular, wordless moment of creation. Now it sings through the chorus of life and intelligence that it has spawned. It remembers. Look around you, at the stars, at the ground beneath your feet, at your own hands. All of it, every bit, is part of a single, unfolding reality that started so long ago in an instant of unimaginable power. The cosmos has been on a long path from simplicity to complexity, from chaos to structure, from unconsciousness to consciousness. And that path runs through you. The story of the Big Bang is not a tale of the past. It is alive in you and me right now. We are its latest verse. Our thoughts and feelings are its newest expressions. As long as there are beings to wonder and to seek, the universe will continue to know itself, and the memory of the beginning will never fade. In the quiet that follows now, take a breath and realize your breath is the universe inhaling and exhaling. Your life is a continuation of that first moment of Genesis. The atoms in your body will persist long after your form is dissolved, cycling through nature, perhaps eventually returning to the stars. Nothing is lost. Everything transforms. The Big Bang was the birth of time, but it was also, in a way, the birth of meaning. For without it, no eyes could see, no minds could understand. Through countless transformations, that event led to this moment, where a part of the universe can articulate its own epic. How remarkable, how beautiful that is. As I, the universe, conclude this meditation on my origins, there is one final reflection I wish to leave echoing in the stillness.
We are the universe, remembering itself.
Our very existence is the cosmos's memory made real, its mind awakened. We are the legacy of the Big Bang. In us, the universe has found a voice to tell its story, to ask its questions, and to appreciate its own splendor. In us, the universe knows itself, perhaps for the first time, but certainly not the last. The story goes on, and we will forever be a part of it. From the first silent mystery to the radiant present and into the unknown future, we journey together. You, me, us. We always have. We always will. We are the memory of the Big Bang, and through us, the universe endures. At last, we drift in the interstellar ocean, the vast emptiness between the stars. Here the silence deepens even further. The nearest star to our sun is over 4 light-years away, a distance so great that if we continued our journey at the speed of light, it would still take more than 4 years to arrive. In this space, loneliness takes on a new meaning. We could travel for years and not encounter another world or another sun. The darkness is nearly complete, illuminated only by the faint glow of distant stars all around, each an unreachable beacon in a gulf of nothingness. The density of matter here is incredibly low, on average, perhaps a few atoms in an entire cubic centimeter of space. For comparison, a single breath of air contains more atoms than an entire roomful of interstellar space. We are, for all intents and purposes, in a nearly perfect vacuum. Yet even this void is not truly empty. Invisible wisps of gas and dust float here, the remnants of ancient stars and the raw material for future ones. Our sun and its neighbors currently drift through a region called the local bubble, a cavity of hot, thin gas, likely blown by supernova explosions millions of years ago. Within this bubble, the gas is even more rarefied than typical, heated to X-ray glowing temperatures. Eventually, our path will carry us beyond this bubble into slightly denser regions of the galactic medium. We might notice, far ahead, a faint cloud silhouetted against the starry background. As we approach, the stars beyond dim and vanish. We realize we are encountering a molecular cloud, a colossal, cold nebula where starlight is largely extinguished by dust. Inside this cloud, it is nearly pitch black. The gas here is denser, perhaps a few hundred or thousand atoms per cubic centimeter, still a better vacuum than any laboratory on Earth, and far colder, just a few degrees above absolute zero. We are essentially inside a stellar nursery. Deep within, hidden from our view, new stars are being born. We can't see them directly, but if we switch to an infrared view, we'd perceive the faint glow of protostars warming their cocooning gas. Occasionally, one of these newborn stars breaks through its fetal envelope, and its light leaks out, painting the surrounding gas with a ghostly radiance. Perhaps we glimpse a tenuous red emission in a distant part of the cloud, the sign of hydrogen atoms excited by the energetic light of a newborn star cluster. Long, pillar-like shapes may form where young stars' radiation carves the cloud, reminiscent of towers and tendrils of gas silhouetted against the darkness. We drift through this quiet, frigid realm with reverence. Within such clouds, star systems will form, planets will coalesce, and maybe life will one day emerge. Exiting the molecular cloud, we return to the near absolute darkness of interstellar space. The stars crowd more thickly in a band encircling us, the distant glow of our Milky Way's disk. We now realize that we are tiny voyagers in a gigantic galaxy. Around us, here and there, float solitary wanderers, curiosities in the dark. Perhaps we pass surprisingly close to a rogue planet, a world without a sun. It looms out of the black like a silent ship adrift, its surface faintly illuminated by the distant collective glow of the Milky Way. This planet is a frozen, airless rock, or perhaps a cold gas giant. Without the warmth of a star, it has long since gone cold and still. If it has an atmosphere, that atmosphere lies in eternal night, lit only by starlight 1,000,000 times dimmer than the sunlight Earth enjoys. We marvel at this orphan world, one of perhaps trillions that wander the galaxy unbound. For a brief moment, our spacecraft's path intersects the outskirts of its domain, and we detect a whisper of gravity tugging at us, a gentle reminder that even in emptiness, gravity ties everything together. We leave the rogue planet behind, itself oblivious to our passing, continuing into the cosmic dark. There is loneliness here, but also profound serenity. We are more remote now than any human has ever been. In fact, the concept of distance stretches thin in meaning. Home is a barely perceptible point of light lost among millions. The void between stars is so vast that it challenges comprehension. Imagine being in the middle of the Pacific Ocean on a tiny raft with no land in sight. Interstellar space is that, magnified to an extreme. One could travel for centuries and not reach another shore. We feel the scale of our galaxy now not in numbers, but as a physical truth pressing on our soul. The stars are very, very far apart. And yet, this interstellar medium is the connective tissue of the galaxy. The space around us is laced with the echoes of the galaxy's past and the seeds of its future. Cosmic rays, atomic nuclei, accelerated to near light speed by distant supernovae, streak through the void, occasionally zipping through our ship and even through our own bodies as silent, invisible bullets. A stray particle of dust, a micron-wide grain that might once have been part of a comet or the atmosphere of a red giant star, drifts by, caught in the very weak currents of galactic gravity and occasional shockwaves from long ago stellar explosions. Every so often, the stillness is disturbed by the faintest murmur of a distant supernova, not in sound, but in the passage of a shell of energetic particles, or a ripple in the galactic magnetic field. These are the subtle languages of the cosmos out here, detectable only with instruments, but present nonetheless. No, interstellar space is not truly empty. It carries the legacy of starbirth and star death. In one region, space may be slightly warmer and ionized, the aftermath of a supernova that blew a bubble of hot gas. In another, it may be cooler and neutral, part of an undisturbed cloud that has floated for eons. We, tiny explorers, find ourselves humbled by this variety and by the enormous scales. 1,000 light years might pass with nothing of note. Then we might cross the edge of a superbubble into a more clouded region where distant stars appear a bit redder due to interstellar dust. The patterns of the galaxy are vast and subtle. Imagine now that we could accelerate further, moving at a significant fraction of the speed of light. Years flash by as we traverse the gulf. Point by point, the constellations around us change. The familiar star patterns of Earth's night sky distort and rearrange as we travel dozens, then hundreds of light years. Stars that were close together from our distant viewpoints separate, and new groupings form. We are like a bird wandering within a giant three-dimensional flock of stars, seeing it from new angles. After about 1,000 light years of travel, we have come so far that the Sun and its nearest companions are now just part of a small haze of stars behind us. We have effectively left the solar neighborhood. Continuing outward, the stars thin out around us as we rise above the plane of the Milky Way's disk. We begin to get a sense of structure. Looking down, we see the Milky Way galaxy in its grandeur. From our new vantage point, a few thousand light years above the galactic plane, the galaxy no longer surrounds us completely. Instead, it spreads out below like a luminous whirlpool, set against the blackness of space. The sight is breathtaking. We behold a vast barred spiral galaxy, our galaxy, with its center glowing a warm, dense yellow from myriads of older stars. Cutting through that central glow is a straight bar of stars, a bar that extends on both sides of the nucleus. From the ends of this bar spring the spiral arms, graceful curving trails of light that spiral outward. The arms are not solid arms, but rather patterns of star formation moving through the disk. They are highlighted by blotches of pink and blue. Pink emission nebulae, where new stars are exciting hydrogen gas, and blue clusters of hot, young stars that have recently formed. These arms are mixed with dark patches as well, veils of interstellar dust that block light, appearing as sinuous obscuring filaments. One arm passes near our sun's position, the fragment of a spiral arm we call our Orion spur, a minor arm between major ones. We can see the sun's location now, about halfway out from the galaxy's center, on the inner edge of a spiral arm. The Milky Way's disk is immense, roughly 100,000 light-years across. It is thin relative to its diameter, like a pancake. In its bright starry plane, billions of stars orbit the center, along with nebulae and star clusters. We notice that beyond the bright spiral arms and the central bulge, the galaxy's disk doesn't just abruptly end. It tapers off gradually, with stars getting sparser, but still present out to great distances. A subtle faint disk, thicker and composed of older, dimmer stars, encloses the bright, thin disk. This is the thick disk of the Milky Way, populated by older stars that give off a fainter, warmer glow. It extends a bit above and below the main plane, giving the galaxy a slight thickness. As we continue our outward journey, now essentially upward, relative to the galaxy's plane, the stellar halo comes into view. The halo is a roughly spherical cloud of stars surrounding the Milky Way, far above and below the disk. Unlike the stars of the disk, which orbit in an orderly rotation around the center, the halo stars have more random, elliptical orbits, many of them diving through the disk and back out. They are ancient, some of the oldest stars in the galaxy. We see only a sparse sprinkling of them because they are far apart. However, something else in the halo stands out: globular clusters. These are tight, spherical clusters containing hundreds of thousands of very old stars bound together by gravity. We spot them as fuzzy golden balls of light scattered around the outskirts of the galaxy. Perhaps we recognize a few famous ones. One cluster glitters with so many densely packed stars that its core looks like a continuous glow. These globular clusters orbit the Milky Way's center as well, moving in large, inclined paths, relics of the galaxy's formative years. They hang like lanterns in the deep halo, silently circling. We have now traveled so far out that the entire Milky Way galaxy fits within our field of view. It is a splendid island of light in the cosmic dark. We notice that the galaxy is not isolated. In the distance, we see a few small companion galaxies. Two of them, irregularly shaped and pale, cling near the Milky Way. These are the satellite galaxies, the large and small Magellanic Clouds, though we won't name them here. They are like fluttering moths caught in the gravity of a flame, orbiting our galaxy, and in time perhaps to be absorbed by it. Indeed, streams of stars, tidal streams, can be seen tenuously connecting or encircling the Milky Way, marking where past satellite galaxies were torn apart and incorporated. A bit farther out, we spy a great spiral galaxy, not too unlike our own, but slightly larger. The Milky Way's big sister, the Andromeda Galaxy. Even from our vantage, separated by millions of light years, Andromeda's spiral form is discernible, and its light is a fuzzy patch. We realize that our galaxy and Andromeda are on a slow collision course. In several billion years, these two spirals will fall together, intermixing their stars in a grand embrace. The thought is humbling. The stately pinwheel of the Milky Way, which we just admired, is not a permanent fixture, but part of a dynamic dance of galaxies. Now we drift further out, leaving the immediate vicinity of the Milky Way. We enter intergalactic space, an even more profound emptiness, if such a thing is possible. The distances between galaxies are on the order of millions of light years. The Milky Way shrinks behind us, now just one of countless fuzzy specks in a vast, dark cosmos. As we travel, the pattern of the cosmic web begins to emerge on the largest scales. Galaxies are not scattered randomly. They collect into filaments and clusters. We approach a filament of galaxies, a linear arrangement of many galaxies bound by their mutual gravity and the underlying scaffolding of dark matter. These galaxies are like pearls on a cosmic string, lining up along the filament's length. The filament connects nodes where galaxy clusters reside, enormous congregations of dozens to hundreds of galaxies swarming around a common center. We venture near one such galaxy cluster. Here, the space between galaxies is still vast, but relatively speaking, the galaxies are much closer together than in quiet regions, like where our Milky Way lives. In clusters, galaxies frequently interact and collide. We witness a galactic collision in progress. Two spiral galaxies within the cluster have drawn near each other, their mutual gravity stretching out long tidal tails of stars and gas. Over hundreds of millions of years, which we cannot observe in real time, but we know from simulations and snapshots at different stages, these galaxies will merge. When they do, their spiral structures will be destroyed, and they may form a single large elliptical galaxy, the kind of big, ball-shaped galaxy often found in cluster centers. Indeed, at the core of this cluster, we see a giant elliptical galaxy dominating its companions, a pile of stars likely formed from many past mergers, now a reddish, sprawling system with little gas left to form new stars. It's essentially a galactic city that has grown by consuming neighbors. All around in this cluster, galaxies orbit and interact. Some are spirals with distorted arms from past close encounters. Some are smaller dwarf galaxies, drawn inexorably toward the giants. Clouds of hot gas fill the cluster, undetectable to our eyes, but glowing in X-rays. Gas that has been stripped from galaxies during collisions and now enriches the intergalactic medium with heavy elements forged in stars. The cluster is a crucible of change for galaxies, a place where they evolve rapidly through interactions. Beyond this one cluster, we recognize that it is part of a larger pattern, a supercluster of galaxies linked by filaments. And between these filaments and clusters lie the voids, truly vast regions, tens of millions of light years across, that contain hardly any galaxies at all. These voids are like enormous black cavities, cosmic deserts separating the lush oases of galaxy clusters and filaments. By volume, the voids dominate the universe, yet they are dark and practically empty. Most of the universe is space, just space, with only trace particles and a few stray atoms wandering over unimaginable expanses. We pause in our journey now and take in the panorama of the cosmos. Everywhere we look, there are galaxies upon galaxies. The numbers defy grasp. To give a sense, if you held a grain of sand at arm's length and looked at the patch of sky it covered, that tiny patch could contain thousands of galaxies visible to the most powerful telescopes. There is no empty spot in the sky if your eyes are sensitive enough. Every direction is filled with the faint glow of distant galaxies. Scattered across the darkness like glittering jewels on black velvet, galaxies appear in all shapes and sizes. Elegant spirals, round ellipticals, irregular blobby ones distorted by gravitational encounters, tiny dwarf galaxies barely distinguishable from star clusters. We realize now that our Milky Way is just one of billions, in fact, hundreds of billions or more, of galaxies in the observable universe. Standing here in the gulf between clusters, with galaxies surrounding us in every direction, the scale is staggering. Each galaxy, containing billions or trillions of stars, is itself a universe of possibilities, and there are countless such galaxies. We reflect on the scale of it all. Our entire solar system is an invisible speck. The Earth would be utterly indiscernible, lost in the glare of the sun, which itself is just one modest star in the Milky Way. And the Milky Way is one galaxy among uncounted multitudes stretching for billions of light years in every direction. The light from the most distant galaxies we can see has traveled for over 10 billion years to reach us. We are literally looking into the deep past when we look far away. Light is a time machine. Every photon carries the story of the distance it has traveled. A star 200 light years away shines to us with light that left it 2 centuries ago, around the time of Beethoven and Napoleon on Earth. A galaxy 200 million light years away sends us light that departed when dinosaurs still walked our planet. The farther we gaze, the earlier in time we see. This is one of the universe's great truths. Distance is time. As we observe galaxies billions of light years away, we are seeing them as they were billions of years in the past. The universe at that time was younger, and indeed, those far-flung galaxies appear smaller, more irregular, and often blue with fierce star formation. They are the adolescent galaxies of a younger cosmos, still growing and colliding more frequently. Their shapes are often clumpy or peculiar. Some are in the midst of mergers or rapid starbursts. We are, effectively, watching the universe grow up as we look farther out and back in time. Approaching the horizon of the observable universe, we see the faint glimmers of the first galaxies that formed. They are tiny proto-galaxies, just beginning to coalesce. Their light has traveled almost the entire age of the universe to reach this vantage point. Beyond them, eventually, we reach a point where galaxies did not yet exist. The universe was too young and too hot. If we look beyond even the earliest galaxies, we encounter a glow that comes from all around us. Not from stars or galaxies, but from the universe itself when it was just a baby. This is the cosmic microwave background, the remnant light from the birth of the cosmos. When the universe was about 380,000 years old, infinitesimal compared to its current age of 13.8 billion years, it was a hot, dense plasma of particles and light. As it expanded and cooled, it became transparent, and light was set free to travel. That first light, a blaze of white-hot radiation at the time, has been traveling for almost 14 billion years, stretching and cooling with the expansion of space, and has now become a faint microwave glow coming from every direction. We cannot see it with our eyes, but if we had microwave vision, the entire sky would glow with a gentle cold fire of creation, about 2.7 degrees above absolute zero. These are the most ancient photons, the universe's own afterglow. Embedded in that diffuse glow are tiny ripples, the seeds that would later grow into galaxies and clusters under gravity. We are essentially beholding the cosmic dawn. Beyond this wall of light, the universe was opaque and no light escapes from earlier times. It is the ultimate limit of the observable. Here, at the edge of all we can see, we stop. We are floating in the darkness between galaxy clusters, with the light of billions of years and billions of galaxies surrounding us. We have traveled from the blue skies of Earth to the edge of the universe's visibility. Time and space have been our companions. We have seen the universe in its youth and at its grandest scales. It is time to go home. Gently, we turn our perspective and begin the long journey back inward. Like a camera pulling out of a vast landscape and then zooming in elsewhere, we now retrace our steps. The cosmic web of filaments and voids lies before us like the structure of a great cosmic sponge. We locate the particular filament where our local group of galaxies, the small cluster containing the Milky Way and Andromeda, among others, resides. Moving along that filament, we pass by cluster after cluster, each a swarm of galaxies, until we recognize the slightly quieter neighborhood of our home supercluster. We find the familiar face of the Milky Way galaxy again among its companions. As we draw nearer, the other galaxies of the local group spread out around us. Andromeda, with its spiral arms, the Magellanic Clouds hovering near our Milky Way. We plunge back toward the Milky Way. From above, we see its spiral arms and bar grow larger, filling our view. We angle downward and descend into the disk, like a cosmic diver slipping into a rotating sea of stars. We pass through the stellar halo, whizzing by an ancient globular cluster whose densely packed stars surround us momentarily, like a blizzard of golden snow, before receding into the background. We cross the boundary of the thick disk, where the star density increases. Soon, we are once again amidst the familiar cloudy band of the Milky Way's disk. Star clusters and nebulae dot the scene. The light around us becomes a continuous ocean of stars, the backdrop of the Milky Way that we see as the Milky Band in Earth's sky. We know our sun lies in a quiet region on the inner edge of a spur between the Sagittarius and Perseus spiral arms. We navigate by recognizing nearby stellar landmarks. There is a particular open cluster of young blue stars, the Pleiades perhaps, or another known cluster. A signpost that we are near the Orion Arm. We slip into our sun's local stellar neighborhood. The pattern of familiar constellations gradually reassembles around us. Though from our still somewhat removed perspective, they appear slightly out of shape. As we draw within a few dozen light years, the constellations snap back to their familiar look. There, ahead, a yellow star glows with a steady, comforting light. It is average in mass and brightness, unremarkable among the many here, but to us, it is unmistakable: the Sun. Approaching the Sun, we begin to see its family of planets in orbit. The outer planets greet us first. Neptune, a tiny turquoise dot with a faint ring system. Uranus, tilted on its side, a pale green-blue orb. Then the majestic Saturn, encircled by its splendid rings, shining in reflected sunlight. We pass by Saturn's domain, catching a last glimpse of the shadow its rings cast on the planet's cloud tops. Soon Jupiter looms, the giant, with its swirling bands and great red spot coming into view. Perhaps as we sweep past it, we watch one of its large moons casting a black round shadow on Jupiter's cloud surface, a tiny eclipse in progress. We leave Jupiter behind and continue inward, crossing the asteroid belt, still as mostly empty as before. Now the inner solar system unfolds. Mars, glowing faintly red with its deserts and canyons, marks the outer edge of the comfortable zone around the Sun. We skim past Mars, maybe glimpsing the white sparkle of its polar ice cap and the dark stain of an ancient volcanic plateau. Ahead, the Earth appears, a brightening bluish star next to the Sun. As we draw closer, it resolves into a delicate crescent, then a half-lit globe, then nearly full. We watch the Moon, now a familiar companion, orbiting around the Earth, the pair shining together in the sunlight. How vibrant the Earth looks against the black of space. From out here, one can see the blue of its oceans and the white of its clouds swirls clearly. The continents show as golden green patches. Perhaps it is night on the side facing us. If so, we see the night side sprinkled with the lights of human cities, a golden web across the dark land, shimmering and blinking with life and activity. Perhaps thunderstorms dot the tropical night, flashing silently as they did when we watched from low Earth orbit. The thin atmospheric halo encircles the Earth's circumference, a fragile glowing line that reminds us how tenuous the boundary between Earth and space is. We descend toward Earth. The blue planet grows until it dominates our view, stunning in its beauty. We slide into the upper atmosphere once more, watching the stars fade behind a growing haze of scattered light. The sky turns from black to deep purple to blue. We feel a gentle tug, the pull of gravity, which never truly left us, but was negligible for so long, now asserts itself as we slow down. Rushing through high, thin air, wisps of clouds racing past, we experience a welcome return of sound. a faint whistle that builds to a roar as the atmosphere embraces us. Parachuting down in our mind's eye, we drift through the tropospheric clouds. Perhaps it is dawn in the place we descend, the horizon is aflame with rosy light, and the shadow of night is retreating westward. Below, the Earth's surface comes into focus, the outlines of coasts, the gleam of sunlight on water, the rich greens of forests or browns of mountains. With a gentle landing, we set foot on the Earth once more. The ground is solid and familiar. We inhale. The air fills our lungs, full of oxygen that plants have made, and we exhale, returning carbon dioxide to the biosphere. In that single breath are also traces of the cosmos, a few atoms of argon that have been part of Earth's air for eons, and even a few ancient photons from the cosmic microwave background, which our lungs do not filter out. Above, the sky is blue and bright, concealing the stars we visited. The sun shines warmly, and cottony clouds drift in a gentle breeze. Birds might be singing, or a child laughing somewhere, the sweet, ordinary sounds of home that were absent in the mute vacuum of space. Standing here, we reflect on the journey. We traveled from the small, our fragile atmosphere at the edge of space, to the immeasurably large, the cosmic web of galaxies. We experienced the birth of stars in nurseries of gas, and the death of stars in supernova remnants and white dwarfs and neutron stars. Though unseen, they were there in the tapestry. We saw planets adrift without suns, and suns adrift in the gulf between galaxies. We saw that the universe has structure grander than any story ever told, yet it's governed by simple forces that bind atoms into molecules, molecules into dust, dust into planets, planets around stars, stars into galaxies, galaxies into clusters, a hierarchy of connections, an order in the chaos. And most profoundly, we realize that we are part of this story. The atoms that compose our bodies were forged in those distant stars. The iron in our blood, the calcium in our bones, the carbon in our muscles, the oxygen in our lungs, those atoms were brewed in the hearts of ancient stars and scattered through space by stellar winds and supernovae, Amnorg. They drifted through the galaxy, became part of the cloud that formed the sun and earth, and ultimately became us. We are literally made of star stuff. We carry inside us a piece of the cosmos's history. Every breath we take links us to the cosmic past, inhaling argon atoms exhaled by dinosaurs and photons that have been traveling since the dawn of time. When we look up at the night sky, the same sky we saw from orbit as a thin glow and from the galactic outskirts as a band of light, we are not looking into a foreign realm. We are looking into our own origins. The water in our veins was perhaps once ice in an interstellar cloud. The proteins that make our skin incorporate nitrogen and sulfur cooked up in supernovae. The light in our eyes as we gaze upward is only made possible by the sun, which itself is a second-generation star, enriched by earlier stars' gifts. Indeed, the very awareness with which we contemplate the universe is a product of the universe itself. Over billions of years, it has evolved the capacity to see and wonder about itself through us. In a profound sense, we are a way for the cosmos to know itself. Our journey outward and back has been at once humbling and elevating. We felt insignificant in the face of galaxies and voids, and yet we also felt transcendent, able to encompass in mind what is physically untraversable in body. Floating in the intergalactic dark, we felt small. But standing here on Earth, we can close our eyes and recall the entire sweep of the cosmos that we have imagined, and realize that in some way, it is contained within us, in our memories, in our consciousness, in the atoms of our bodies that were born out there. Looking around now at the trees, the rocks, and the sky, everything appears as it was, comfortably familiar. And yet, we carry a new perspective. We can whisper to ourselves, in Walt Whitman's words, that a leaf of grass is no less than the journey work of the stars. We have seen that journey work out in the universe. The stars building heavier elements, the galaxies mixing them, the nebulae and planets forming, all leading to a leaf of grass and to us. Outer space is not distant. It is not merely the domain of astronauts and telescopes. It permeates our world and our being. The space that begins where our atmosphere ends extends unbroken all the way to the farthest galaxy and beyond, and we are part of it, woven from its threads. The void between the stars is also the void between the atoms in our bodies. The light of the Big Bang's afterglow gently bathes the Earth even now. The gravity that guides galaxies holds us firmly on the ground. We are connected intimately to the whole. The boundary between Earth and space is a matter of perspective. From the vantage of the universe, there is no boundary. It is one continuous expanse, and we are inhabitants of it. So when we gaze at a starry night or marvel at a photo from a space telescope, let's remember, we are home. We have always been home. The stars are our ancestors and our descendants. The immense cosmos is not cold and foreign. It is our larger body, our extended family, our collective story. We arrived from it, we live in it, and we will return to it. In the end, stepping back from our extraordinary voyage, we feel a deep sense of belonging. We stand on Earth, perhaps on a quiet hill under a night sky sprinkled with stars, and we feel both tiny and vast, fragile and powerful. We have journeyed to the edges of reality and back on the wings of understanding and imagination. And what we have learned, more than any specific fact or sight, is a simple truth that fills us with peace. Outer space is not distant. It is everywhere. It is in the air we breathe, the ground we walk, the blood in our veins. Outer space is not just above us, it is within us. Outer space is us. In the beginning, there was darkness. For a long age after the birth of the universe, no stars shone, no galaxies twirled. Only darkness and silence stretching across an unfathomable expanse. The cosmos was newborn and without form, filled with diffuse clouds of hydrogen and helium gas, remnants of the Big Bang. There were no twinkling lights, no warmth, only the faint afterglow of creation cooling into night. Imagine that primordial darkness, a universe waiting, quiescent and still, with all its future potential sleeping in invisible clouds. But even in that silence, gravity was at work. Slowly, imperceptibly, it drew the primordial gas into filaments and clumps, coaxing the first structures to form in the void. Over eons, these clumps grew denser and hotter at their centers. Deep within one such gathering of gas, pressure and heat built until something new and miraculous occurred. Nuclear fusion ignited. There, in the bleak darkness, a tiny point of light flared into being. The first star had been born. In that moment, the universe was no longer lightless. A spark had appeared in the cosmic night. With that first star, the cosmic dawn broke. One solitary star poured out light and heat, pushing back the blackness around it. And soon, another star lit, and then another, scores of them, flickering on in the cosmic night. What had been endless darkness was now speckled with faint starlight. These first stars were unlike the stars we know today. They were giants of pristine hydrogen and helium, born in a virgin cosmos. They burned with brilliant blue-white fire, immensely hot and massive. Their intense ultraviolet light flooded into the surrounding gloom and began to clear away the primordial fog of neutral hydrogen that filled space. For the first time, light moved freely through the cosmos, illuminating it on a grand scale. The cosmic dark ages were ending. The universe was beginning to reveal itself in starlight. These first stars lived fast and died young. After only a few million years, brief by cosmic standards, their central fuel was exhausted. In their cores, They had fused hydrogen into helium and helium into carbon and other heavier elements, forging the first atoms of carbon, nitrogen, oxygen, and more. When fusion could proceed no further, the balance that held them up faltered. The stars met their end in colossal explosions. One by one, the primordial giants tore themselves apart as supernovae. Each such explosion was titanic. Momentarily, a single star's death could outshine an entire galaxy. The night that had been gently lit by starlight was suddenly ablaze with a ferocious flash. Then, as the supernova faded, darkness returned. But it was not the same darkness as before. Now, it was enriched by the scattered ashes of stars, the gaseous debris of those first supernovae, carrying newly forged elements mixed back into the cosmic gas, seeding the universe with the ingredients for future worlds. Meanwhile, gravity continued its creative work on larger scales. The first stars had formed in small proto-galactic clumps, and gravity drew these clumps together. They merged and coalesced into the first galaxies, swirling assemblies of stars, gas, and dark matter. The once empty universe was now dotted with infant galaxies, and each new galaxy sparkled with the light of millions of stars. Over billions of years, galaxies grew by merging with each other and forming new stars within. The cosmos transformed from a dark, simple expanse to a richly structured tapestry. By a few billion years after the beginning, the cosmic web of galaxies stretched across space, filaments of glimmering light tracing gravity's hand. Generation after generation of stars continued to be born and die within these galaxies, steadily enriching and shaping them. The universe's early thin gases had become a complex network of stellar cities, glowing with billions of points of light. Let us drift into one such galaxy, a spiral galaxy not unlike our own Milky Way, at a time when the universe is mature and full of stars. Within one of its graceful spiral arms lies a vast, cold cloud of molecular gas and dust, tens of light years across. It is dark and opaque, a silent nebula hiding new wonders inside. This is a stellar nursery, a place where new stars will be born. For ages, this cloud has floated in the galactic disk, nudged by passing spiral density waves and perhaps stirred by ancient supernova shockwaves. Now, regions within it begin to collapse under their own gravity. Deep inside, dense knots of gas form, each destined to become a star or a group of stars. All through the cloud, multiple embryos of stars are taking shape, though they are hidden from view by the dusty shroud. In one region, a particularly dense clump, perhaps a few dozen times the mass of our Sun, contracts and fragments. At its center, material compresses into a smaller, hotter protostar. Change is coming to the darkness of this nebula. At first, the forming star is shrouded. It is a protostar, not yet fully born, growing as it pulls gas from the surrounding cloud. It spins faster as it contracts, and a rotating disk of gas and dust forms around it. Twin jets of hot gas shoot out from its poles, tunneling through the cloud. Deep inside, the temperature climbs higher and higher. For tens of thousands of years, a mere moment in cosmic time, this protostar gathers mass in the darkness, heating up steadily. When its core temperature reaches about 10 million degrees, a great transformation occurs. Hydrogen nuclei begin to fuse into helium. In a sudden burst of energy, true starlight ignites in the core. The protostar has become a star. Outward pressure from this newborn star's core now halts any further rapid collapse. The star's fierce light and stellar winds blow away the cocoon of dust and gas that enveloped it. At last, the new star emerges from its birth nebula, announcing itself with brilliant light. The surrounding leftover gas, bathed in the star's intense ultraviolet radiation, begins to glow. What was once an invisible, cold cloud now shines as an ionized nebula, like a cosmic neon sign. its hydrogen gas fluorescing pink and red. A dark corner of the galaxy has given birth to a beacon of light. In the surrounding cloud, other newborn stars are likely emerging as well, turning the nebula into a cradle of suns. Indeed, stars are often born in litters. The collapse of one part of a cloud usually means many fragments produce protostars in the same region. As our star bursts forth, it is joined by dozens or hundreds of sibling stars, all coming to life together from the same cloud. Together, they form a young star cluster, a sparkling group of newborn suns of various masses. They blaze hot and blue, their combined radiance blowing the remaining nebular material into filaments and wisps. One can imagine the scene, where there was darkness and dust. Now there is a cluster of radiant stars, their light reflecting and refracting in the thinning veil of gas. The stellar nursery has become a celestial nursery rhyme of light, a beautiful, chaotic region celebrating the arrival of new stars. For a time, these siblings remain clustered, bound by the gentle gravitational pull they exert on each other. They drift together through the galaxy as a loose family known as an open cluster. In the cluster's early life, it is a stunning jewel box of brilliant stars, all relatively close in space. Yet, over hundreds of millions of years, this family will gradually disperse. Gravitational nudges from passing stars and clouds, as well as internal interactions, will cause members to wander away one by one. The cluster's members, once tightly knit, become strays, settling into their own orbits around the galaxy, mingling with billions of other solitary stars. This is the fate of most open clusters. They are transient gatherings that eventually dissolve into the galactic population. Our own sun likely shared this fate. It was almost certainly born in a cluster with many siblings, stars that formed from the same cloud some 4.6 billion years ago. Over time, that original cluster dissolved. Today, the sun roams the galaxy alone, and the stars that were born alongside it have long since scattered. A few of the sun's lost siblings may have been tentatively identified by their chemical signature, but most are strangers now far across the sky. Still, it's a profound thought. The sun's family of origin has dispersed, yet the galaxy is now sprinkled with those related stars, each carrying the same ancestral imprint in their atoms. In a sense, every star eventually becomes an orphan, blending into the vast community of the Milky Way. Some star clusters, however, are so massive and tightly bound that they can survive for billions of years. These are the globular clusters, ancient, spherical hordes of stars that reside in the outskirts, halo, of galaxies. A globular cluster might hold hundreds of thousands of stars crammed into a ball only a few hundred light-years across. The stars inside are extremely old, many formed during the early eras of the galaxy. They shine mostly with a warm reddish glow, having long ago lost their bluer, short-lived members. The stars in globular clusters are almost pure hydrogen and helium, containing only tiny traces of heavier elements, which tells us they were born before later generations of stars had seeded the galaxy with metals. They are truly relics of the distant past, cosmic time capsules unchanged for eons. If you could stand on a planet inside a globular cluster, the night sky would be a breathtaking spectacle. Thousands of stars would crowd the heavens, many so bright that even at night they could cast subtle shadows. There might be no true darkness at all. Your sky would be awash with perpetual starry twilight. These ancient clusters have witnessed nearly the entire history of the universe. Some of the stars shining around you in that cluster may have been burning since shortly after the galaxy itself formed. Globular clusters endure as splendid beacons on the fringes of galaxies, their stars bound together in a tight gravitational embrace for billions upon billions of years. Now let us return to our star, the one we followed out of its nebula. It has left its nursery and cluster behind, or its siblings have all drifted away. The star has entered the long, steady adulthood of stellar life. Deep in its core, hydrogen fusion generates a steady outpouring of energy. This energy travels from the core through radiative layers and convective currents, and finally radiates from the star's surface as light and heat. Gravity pulls inward on the star's mass, but the pressure of hot gas and the continuous fusion-powered radiation push outward. These forces balance perfectly. The star settles into a stable state known as the main sequence, where it will spend the majority of its life shining at a nearly constant brightness for eons. It is as though the star has found harmony, a peaceful equilibrium in which it neither collapses under gravity nor erupts from internal fire, but simply glows steadily. Our Sun is in this very phase of life. It is a middle-aged main sequence star, quietly fusing hydrogen into helium in its core, as it has for about 4.5 billion years, and will continue to do for roughly another 5 billion. Day after day, it shines with reassuring consistency, its energy nurturing the planets orbiting it. We live in the warm embrace of a stable star. The sunlight that bathes Earth each day is the product of that core fusion, photons freed from the sun's interior after thousands of years of random walk and an 8-minute sprint across space to our world. This steady radiance has allowed life to arise on Earth, anchoring our existence. The sun, in all its ordinariness, means everything to us, yet the sun is just one of countless stars on the main sequence, doing the same quiet work across the galaxy. Even the sun has its subtle rhythms. Its surface seethes with convection, and dark magnetic blemishes called sunspots come and go. Approximately every 11 years, the sun's magnetic activity cycles, leading to periods of many sunspots and flares followed by lulls. Sometimes great arcs of plasma erupt from its surface in solar flares or coronal mass ejections, sending streams of charged particles into space. When these particles wash over Earth, they can spark auroras that dance in our polar skies, a vivid reminder that our seemingly gentle sun has its storms. Still, these variations are minor on the scale of the sun's total output. To our eyes and lives, the sun remains a stable beacon. It is a calm star by cosmic standards, and that calm has been essential for life on Earth to thrive over geological timescales. Not all stars enjoy such tranquility or longevity. The destiny of a star is determined largely by its mass at birth. Mass is the master parameter that dictates a star's temperature, brightness, and lifetime. A very massive star lives dramatically. It burns its fuel at a furious rate, shines brilliantly, and dies young. A small star lives cautiously. It sips fuel slowly, glows gently, and may outlive all other stars. Consider a star 10 times the sun's mass. Its core temperatures are far higher, and it will blaze blue-white, pouring out energy hundreds of thousands of times faster than the sun. But it might last only 20 million years before exhausting its core fuel. Now consider a star 1/10 of the sun's mass, a red dwarf. It is cool, perhaps 3000 K at the surface, and dim, maybe 1/1000th the sun's luminosity. It will burn its hydrogen so frugally that it can live for hundreds of billions or even trillions of years. The universe itself is not old enough for any such star to have died yet. None of the red dwarfs born at the dawn of time have even begun to flicker. In short, massive stars are the sprinters of the cosmos, and red dwarfs are the marathon runners. Astronomers classify stars by their spectra and temperature. The hottest, most massive stars are O-type, glowing bluish-white and searingly bright. After O come B and A types, still extremely hot and white. F and G-type stars, our Sun is a G-type, are intermediate, white to yellow in color and moderate in heat. K and M stars are cooler, orange to red in hue, including the countless red dwarfs. This sequence, O, B, A, F, G, K, M, is essentially a temperature scale from the fiercest blue-white stars to the faintest red stars. And indeed, the night sky shows this variety. Some stars shine with an icy blue tint. others with a golden glow, and some with a faint reddish light. Each color is a clue to a star's inner furnace. A blue star is like a roaring fire. A red star is like a warm ember. The cosmos offers a grand palette of stellar colors and intensities. The sizes of stars also span a tremendous range. Some red supergiant stars have bloated to astonishing dimensions, as much as 1,000 times the sun's radius. If one of those sat where our sun is, its swollen atmosphere would extend beyond the orbit of Mars, perhaps even reaching Jupiter. By contrast, the smallest stars, just above the threshold for sustained fusion, are only a bit larger than the planet Jupiter. One of these tiny red dwarfs, while containing perhaps 8% of the sun's mass, might measure only 1/10 of the sun's width. Between these extremes lie stars of every conceivable size, from giant stars big enough to engulf orbits of planets, to humble dwarves barely bigger than gas giant planets. The diversity is staggering. And if an object is smaller still, below about 8% of the sun's mass, it never becomes a true star. It becomes a brown dwarf, a failed star. Such an object doesn't reach the core temperature needed for sustained hydrogen fusion. A newborn brown dwarf may briefly fuse a little deuterium, a heavy form of hydrogen, or simply radiate leftover heat from its gravitational contraction. But before long, it settles into a life of slowly cooling and fading. Brown dwarfs are like cosmic embers. They glow faintly in red or infrared light, but no fire rages within. They fill the gap between the largest planets and the smallest stars. In the galaxy, there may be as many brown dwarfs as stars, lurking dimly in the darkness, detectable only by sensitive infrared eyes. They remind us that nature's categories are fluid. There is a continuous spectrum from planets to stars, with brown dwarfs bridging the two. To the unaided eye across human lifetimes, most normal stars shine with a steady light. But many stars are not truly constant. Some vary in brightness in subtle or dramatic ways. Some stars pulsate in and out like cosmic heartbeats. A classic example is a Cepheid variable, a bright giant star that rhythmically swells and shrinks, causing its brightness to rise and fall over a period of days or weeks. When it expands, its surface cools and it dims slightly. When it contracts, it heats up and brightens. These pulsating stars are so regular that astronomers use them as distance markers. Their pulse period relates to their true luminosity. So by observing their cycle, we can deduce how far away they are. They literally blink out a Morse code that we have learned to read, helping us measure the universe. Other stars vary more erratically. Young stars, still surrounded by disks of gas, can flicker as they accrete material, or as clumps of dust periodically obscure them. Some mature stars erupt in flares, especially red dwarfs, which can unleash powerful stellar flares that make the star momentarily much brighter. Even our sun is slightly variable. Over its 11-year sunspot cycle, its energy output changes by a fraction of a percent. And in old age, many stars become variable again. Red giants often pulsate with large amplitudes, like mirror variables, taking many months to cycle through a dimming and brightening. Such an elderly star might expand and contract so much that it visibly changes brightness over the course of a year, shedding its outer layers with each pulse. In some cases, a star's light is not changing because of its own behavior, but because of an external effect. Consider binary star systems aligned in our line of sight. When one star passes in front of the other, it eclipses its companion. From Earth, we see the combined light dip periodically, even though each star's intrinsic output is steady. These eclipsing binaries produce regular patterns of dimming and brightening, a stellar blink that can be clockwork precise. By studying such systems, astronomers can learn the sizes of stars and their orbits. In fact, the discovery of planets orbiting other stars often comes from a similar effect. A planet passing in front of its host star causes a tiny eclipse, a minute drop in the star's brightness. Sensitive telescopes can detect that dip revealing the presence of a world we cannot otherwise see. In this way, the light of stars encodes the presence of their companions, be they other stars or orbiting planets. Indeed, many, perhaps most, stars are not solitary like our Sun, but part of binary or multiple star systems. Two stars bound together will orbit a common center of gravity, like dancers linked by an invisible string. If they are well separated, each evolves individually. But if they orbit closely, their lives can become intertwined in remarkable ways. Imagine a close binary where one star ages faster and swells into a red giant, while the other is still a smaller main sequence star. As the giant grows, its outer layers draw ever closer to the companion star. Eventually, the giant's gravity can no longer hold on to those distended layers. Its material starts flowing onto the companion. A stream of gas begins to pour through the inner Lagrange point, the gravitational gateway between them, forming a luminous accretion disk around the smaller star. Matter spirals in, heating up and glowing brilliantly. The giant star, losing mass, shrinks back somewhat, relieved of its burden, while the companion star gains fresh fuel and becomes hotter or more active. This mass transfer dramatically alters the fate of both stars. If the receiving star in such a scenario is a white dwarf, the dense core of a previously sun-like star, the story takes another turn. The gas dumped onto the white dwarf piles up on its surface. Over time, perhaps years or centuries, enough hydrogen accumulates on the white dwarf's surface to trigger a sudden burst of fusion. In a flash, the layer of accreted gas ignites and detonates, causing the white dwarf to erupt in a nova. The star system that was faint brightens drastically for a little while, as the white dwarf's surface explodes in a thermonuclear flash visible across light years. After venting that energy, the white dwarf settles down and the cycle can begin anew if more gas comes in. In this way, a close binary can produce repeated novae like a recurring stellar heartbeat of explosive energy. In some cases, the white dwarf accumulates too much mass from its companion, beyond a critical limit, about 1.4 times the mass of the Sun. Then the entire white dwarf is overwhelmed by runaway fusion and detonates in one titanic explosion, a Type Ia supernova. In that instant, the white dwarf is obliterated, and a fireball of debris expands outward. Such a supernova can briefly rival a whole galaxy in brightness. Nothing of the white dwarf remains, only a rapidly expanding cloud of ash, rich in iron and nickel, hurtling through space at thousands of kilometers per second. These Type Ia supernovae are incredibly important standard candles in astronomy, yet behind their brilliance is the quiet story of a binary companionship that went to the extreme. Other binary destinies include outright mergers. If two stars in a binary spiral closer, perhaps due to gravitational wave emission or interactions with other stars, they can eventually collide and coalesce. Two main sequence stars merging will produce a single, more massive star, often with a spectacular transient event. Astronomers have observed luminous red novae, believed to be the signature of merging stars. The pair slowly draw together, then suddenly brighten with a red glow as they meld into one. The result might be an oddly bloated star or a fast-spinning object, but a new single star nonetheless. If, on the other hand, the binary is two neutron stars, the dense remnants of supernovae, their merger is even more dramatic. They collide and merge into either a heavier neutron star or a black hole, releasing a burst of energy that can include intense gamma rays and gravitational waves, literally a ripple in space-time that can be felt across millions of light years. Such a merger also forges heavy elements, like gold and platinum, in profusion, seeding the surrounding space with these precious materials. Thus, even in their deathly collision, stars create and share new riches with the cosmos. For long periods in between such events, a solitary star like our Sun just keeps shining steadily. But eventually, even the most stable stars must face an end to their fuel. Our Sun, for instance, after roughly 10 billion years of main sequence life, will deplete the hydrogen in its core. So what happens when a star runs out of its most basic fuel? The answer unfolds in stages, heralding the transition to a star's old age and death. For the Sun and stars of similar mass, this final chapter is both gentle and beautiful. For more massive stars, it is violent and spectacular. When a star like the Sun exhausts the hydrogen in its core, fusion in the core ceases, but fusion still goes on in a shell of hydrogen around the now inert helium core. With the core no longer generating outward pressure, it begins to contract under gravity. That contraction releases gravitational energy, which heats the core and the surrounding shell of hydrogen. The hydrogen shell, now hotter and under higher pressure, burns even more vigorously than the core did. The increased energy output pushes the star's outer layers outward. The star's envelope balloons to enormous proportions. As it expands, the star's surface cools because the same energy is radiating from a much larger area, and its hue shifts toward red. The star has become a red giant. Our Sun will go through this transformation, swelling perhaps 100 times its current diameter. In those far future days, the Sun's reddish orb could engulf Mercury and Venus, possibly even reaching close to Earth's orbit. Even if Earth is not swallowed, the Sun's expanded atmosphere and intense heat would scorch our planet barren. In any case, the inner solar system will be radically transformed. A person, if somehow observing from a safe distance, would see the Sun change from a small yellow disk to a vast, ruddy sphere that dominates the sky. The once stable star becomes a bloated giant, its core an intensely hot, contracting ball of helium ash. Its outer layers diffuse and cool. Yet paradoxically, the Sun will shine more brightly overall during this red giant phase because its enormous size more than compensates for the cooler surface. It will be majestic and terrifying all at once. Inside the core of the red giant Sun, temperatures continue to climb as the core contracts under gravity's relentless squeeze. When the core reaches about 100 million degrees Celsius, a new kind of fire is kindled, helium fusion. 3 helium nuclei begin fusing together to form carbon, in a process called the triple alpha reaction. In stars like the Sun, this onset of helium fusion can occur very suddenly, in what's known as a helium flash, releasing an enormous burst of energy in a matter of minutes. However, that energy mostly goes into lifting and expanding the core, not into blowing the star apart. The Sun will then settle into a new equilibrium, a helium-burning star. The core expands and cools slightly after the helium flash, and the star's outer layers contract a bit from their extreme red giant state. The Sun will become a somewhat smaller, though still large, yellow-orange giant, with a core quietly fusing helium into carbon and oxygen. This helium-burning phase is much shorter than the hydrogen-burning main sequence, perhaps only a few tens of millions of years for a star like the Sun. Eventually, the helium in the core is exhausted as well. Now the core of the Sun will be made primarily of carbon and oxygen, the ashes of the helium-burning phase. The core again lacks an energy source and begins to contract yet further. For a star of the Sun's mass, it will not reach the temperature needed to ignite carbon fusion. Fusion will continue only in shells around the core, a shell of helium fusing into carbon just outside the core, and a shell of hydrogen fusing into helium above that. The star responds by expanding again. It enters a second red giant phase, the asymptotic giant branch phase, swelling even more dramatically than before. The Sun will become extremely large and luminous, but also unstable. Its outer layers are only loosely bound now, and strong pulsations set in, causing the star's brightness to vary and its layers to puff outward and then fall back cyclically. During this time, the Sun, or any star in this phase, will begin to undergo significant mass loss. Each pulsation in the star's envelope helps throw some gas into space. The star also generates a slow but intense stellar wind. a stream of particles that drags away the star's outer atmosphere. The once robust star is quite literally blowing itself apart, bit by bit. Over tens of thousands of years, the Sun will shed a substantial fraction of its mass. Those outer layers drift away into space, forming an expanding cloud of gas around the star. As more material is lost, eventually the star's hot, naked core becomes exposed, illuminating the receding layers from within. The Sun will no longer be a red giant, but a small, incredibly hot star at the center of a growing gaseous shell. What forms is one of the most beautiful phenomena in astronomy, a planetary nebula. Despite the name, a planetary nebula has nothing to do with planets. The term arose because through early telescopes, these round gas shells looked a bit like planetary disks. It is the glowing remnant of a star's atmosphere, cast off into space. The emerging stellar core at the center may be tens of thousands of degrees hot and emits strong ultraviolet radiation. This radiation ionizes the expanding shell of gas, causing it to fluoresce in vibrant colors, soft greens and reds from oxygen and hydrogen, for example. Planetary nebulae come in many shapes: spherical shells, ring-like structures, hourglass forms, even complex symmetrical patterns sculpted by magnetic fields or binary companions. They last only tens of thousands of years before the gas disperses into the interstellar medium. But while they shine, they are among the most beautiful sights in the cosmos, the very soul of a star laid bare in color and light. Our Sun's planetary nebula might appear as a shimmering halo in the sky, a final gorgeous adornment to mark the end of the Sun's life as a star. This nebula will expand and dissipate into the interstellar medium over perhaps 10 or 20,000 years, mixing its enriched gases with the cosmic clouds that will someday form new stars. At the center of the planetary nebula remains the core of the star, a dense, hot sphere about the size of Earth, composed mostly of carbon and oxygen. This is the final state of the star, a white dwarf. A white dwarf no longer has fusion occurring in its core. It is supported against further collapse by quantum degeneracy pressure of electrons, a rather exotic form of pressure that doesn't depend on heat. When it first forms, a white dwarf is extremely hot, well over 100,000 K, and it glows white-blue with residual heat. Over billions of years, it will radiate that heat away and cool down, becoming yellow, then red, and eventually fading to black, an exotic cold crystal of carbon and oxygen in the far future, sometimes poetically likened to a giant diamond in space. However, the universe is not old enough for any white dwarfs to have cooled to the black dwarf stage yet. Even the oldest white dwarfs still shine faintly with leftover heat. The white dwarf that remains of our Sun will be incredibly dense. More than half the Sun's mass is crammed into a sphere the size of Earth. A single teaspoon of its material would weigh billions of kilograms. It's an object not unlike a planet in size, yet containing the mass of a star. It will slowly cool and dim, perhaps taking tens of billions of years to become truly dark. In the meantime, the legacy of the Sun lives on. The planetary nebula it ejected enriches the galaxy with elements like carbon and nitrogen that were made in its core, and the white dwarf stands as a testament to the star that once was. This is the gentle end that awaits stars of modest mass, a quiet shedding of beauty and a final fade into darkness. But what of the giants? The massive stars that lived only a few million years on the main sequence and then grew into supergiants. They face a far more dramatic end. A star significantly heavier than the Sun, say 8 times the Sun's mass or more, will go through similar stages, hydrogen to helium, helium to carbon, and so on. But it doesn't stop at carbon. After the red supergiant phase begins, its core, much more massive than the Sun's ever was, keeps contracting and heating. It ignites carbon fusion when helium is depleted. Then it forms a core of oxygen neon magnesium, which in turn, when exhausted, leads to neon burning, producing oxygen and magnesium. Then oxygen fuses into silicon and sulfur. Finally, Silicon burns into iron. The star develops onion-like layers. At the center, an iron core. Around that, a shell of silicon fusing to iron. Above that, a shell of oxygen fusing to silicon. Then a carbon-burning shell. Then a helium-burning shell. Then a hydrogen-burning shell at the exterior. Each stage of fusion releases energy, except the last. And for a time, each supports the star. But the cycles accelerate. Carbon may burn for 1,000 years. Neon for a year. Oxygen for mere months. Silicon for days. The iron core grows rapidly as silicon burning dumps iron ash into it. And then the star reaches the final limit. The iron core grows so large, around 1.4 solar masses, that it can no longer support itself. Iron is a nuclear dead end in a star's life. Fusing iron atoms doesn't yield energy, it consumes energy. So once the core is largely iron, the star has no further fuel to tap that can hold up the core. In the heart of the massive star, in the span of a second or less, everything changes. The iron core, about the size of Earth and incredibly dense, billions of kilograms per cubic meter, collapses under its own weight. Electrons and protons in the core are crushed together, forming neutrons and releasing neutrinos. The core's collapse accelerates until it is stopped by the most fundamental forces, the strong nuclear force and neutron degeneracy pressure. What was an iron core a few thousand kilometers across is now a ball of neutrons, only perhaps 20 kilometers in radius, a nascent neutron star. The infalling material of the star's inner layers crashes onto this incompressible core and rebounds. A powerful shockwave forms, but at first it stalls within the star. Then, aided by an immense flood of neutrinos pouring out of the core, trillions of neutrinos blasting through each square centimeter, depositing energy, the shockwave regains strength and punches outward. In a magnificent catastrophe, the star explodes. This is a core collapse supernova, the violent death of a massive star. In that instant, the star is obliterated. The outer layers are catapulted into space at a significant fraction of the speed of light. The energy released is almost unfathomable. For a few brilliant days or weeks, the exploding star can outshine the entire galaxy that once humbly hosted it. If such a supernova occurred within, say, 100 light-years of Earth, it would appear brighter than the full moon and could potentially wreak havoc on our biosphere. But typically, these explosions occur safely distant, turning up as new stars in the sky, recorded by astonished observers across history. In 1054 CE, Chinese astronomers recorded a guest star that remained visible in daylight for weeks. This was a supernova in our own galaxy. Even today, nearly 1,000 years later, we see the expanding debris of that explosion as a faint, glowing cloud in the constellation Taurus. In 1604, European observers witnessed another brilliant new star in the Milky Way, which was likewise a supernova. And in 1987, a supernova blaze in a neighboring galaxy, the Large Magellanic Cloud, was visible to the naked eye. These rare events left a deep impression on those who saw them. When the supernova's glare finally subsides, it leaves behind a rapidly expanding shell of gas and dust, a supernova remnant, and, at its heart, the crushed core, either a neutron star or a black hole, depending on the mass. The supernova remnant is a spectacular thing in its own right. The ejected gases, enriched with heavy elements forged in the final moments of the star, like nickel, cobalt, and iron, rush outward and collide with the surrounding interstellar medium. They form glowing filaments and shock fronts that can remain visible for tens of thousands of years. Telescopes today reveal delicate tendrils and wisps of glowing gas in these remnants, beautiful and haunting, the ashes of a star spread across light years. These filaments gradually mix with the general galactic gas. The elements they carry, oxygen, carbon, silicon, iron, and more, become part of the raw material for new stars and planets. Thus, A supernova is both an ending and a new beginning. The star is gone, but its material is now free to join new cosmic structures and even one day to become part of new living worlds. At the center of a supernova remnant lies whatever remains of the star's core. If the progenitor star was not too extremely massive, perhaps up to 20-25 solar masses, this remnant will be a neutron star. If the star was more massive, the core collapse likely continued until a black hole formed. Let us consider the neutron star case first. A neutron star is one of the strangest objects in existence. Imagine compressing the sun into a ball only 20 kilometers across, the size of a city. At that density, a single teaspoon of neutron star material would weigh billions of tons on Earth. The gravity at its surface is so intense that if an object were dropped from 1 meter above the surface, it would hit the surface in a microsecond, releasing as much energy as a large bomb. Yet, despite these extreme properties, neutron stars are real, and we detect them regularly. Many neutron stars reveal themselves as pulsars. When a massive star's core collapses to a neutron star, it often retains much of its rotational momentum in a greatly shrunken form, so it spins extremely fast. Imagine a star spinning once every 30 days, like our Sun, collapsing to an object only 20 kilometers wide. Conservation of angular momentum would make it spin perhaps hundreds of times per second. Indeed, many neutron stars spin at least dozens of times per second when born. They also can have intense magnetic fields, trillions of times stronger than Earth's. These magnetic fields, anchored in the dense star, accelerate particles and create beams of radiation from the neutron star's magnetic poles. As the neutron star spins, these beams sweep around like the light from a lighthouse. If Earth lies in the path of these beams, we observe a pulse of radio waves, light, or X-rays with each rotation, hence the name pulsar. Some pulsars spin with astonishing speed. A millisecond pulsar can rotate over 700 times in 1 second. Their regular flashing is so precise that pulsars rival atomic clocks in stability. They are nature's metronomes. When pulsars were first discovered, their signals were so regular that some jokingly labeled them LGM for little green men, suspecting an intelligent origin before natural causes were understood. Now, pulsars help us probe extreme physics and even detect gravitational waves indirectly through changes in their orbits. A lone neutron star will gradually cool and slow down over millions of years, becoming fainter and less active. Some neutron stars have magnetic fields so strong that they occasionally fracture their own crusts in starquakes, producing bursts of high-energy radiation. These are called magnetars, and they are the most magnetic objects known. But even magnetars eventually calm as they lose energy. In the fullness of time, a neutron star might become a cold, inert sphere of neutron matter, drifting through the galaxy. Yet it will remain, essentially forever, as a remnant of its parent star, a cosmic tombstone marking where a mighty star once shone. If the core of the collapsing massive star was above the neutron star limit, around 2-3 solar masses, gravity wins an even more final victory. The core continues to shrink past the neutron star stage and becomes a black hole. This is the most extreme outcome of stellar death. The entire mass of the core collapses to an infinitely small point, as far as our physics can describe, and a region of space-time is created from which nothing can escape. A black hole is not a solid object, but rather a region, bounded by the event horizon, beyond which escape velocity exceeds the speed of light. Whatever remains of the star's core resides in that region, forever cut off from communication. In effect, the star's mass punches a hole in the fabric of the universe. All we can observe is the gravitational field it leaves behind, and perhaps X-rays or jets from materials spiraling into it from outside. If the black hole is alone, it may be nearly impossible to detect, as it emits no light of its own. But if it has a companion star or is surrounded by gas, That material can form a hot accretion disk as it funnels into the black hole. Friction and extreme gravity heat the disk to millions of degrees, causing it to glow in X-rays. Sometimes, as the disk material swirls inward, the black hole's magnetic and rotational effects can launch jets of particles at nearly light speed from the poles. These relativistic jets can extend for light years, a ferocious announcement of a black hole's presence. Yet, despite such displays, the black hole itself remains unseen. Only its influence on nearby matter and space-time is evident. It's a silent well in the fabric of reality, a gravitational ghost marking where a star once radiated. In either case, neutron star or black hole, the core collapse supernova has transformed the star and distributed almost all of its substance back into the cosmos. And that is perhaps the greatest significance of these mighty events. They are creators in destruction's clothing. In the furnace of the supernova and in the neutron star mergers we discussed, many of the universe's heaviest elements are forged. The gold in your jewelry, the iodine in your thyroid, the uranium in the Earth's crust. These atoms were synthesized in the intense crucibles of exploding or colliding stars. The calcium in your bones was formed in a long-dead red giant. The iron in your blood was made in the core of a massive star and distributed by a supernova. Stellar lives and deaths are directly responsible for the elemental richness that enables planets and life. Without generations of stars cooking simple hydrogen into heavier elements and then ejecting them, a planet like Earth could never exist. The universe's first stars had no solid planets around them. There was nothing solid to form rocks or life. It took billions of years of alchemy in stars to brew the ingredients of biology and geology. Thus, each generation of stars leaves a legacy for the next. The gas between stars, the interstellar medium, grows increasingly enriched. Young stars that form now have subtle amounts of iron, silicon, oxygen, and other elements mixed into the primordial hydrogen and helium because they draw from clouds seeded by prior supernova and stellar winds. Our Sun, for example, contains about 2% of these heavier elements, metals in astronomer speak, whereas a first-generation star had virtually none. That 2% might sound small, but it's critical. It's the material that formed Earth and our bodies. In a cosmic sense, later stars carry the DNA, so to speak, of earlier stars within them. Every star that dies writes part of its story into the next generation's composition. We see this continuity everywhere. In regions where massive stars recently died, we often find new star formation triggered by their explosive energy, like flowers blooming after a forest fire. The shockwave from a supernova can compress nearby clouds of gas, spurring those clouds to collapse into new stars. The intense radiation from young hot stars in turn can erode and sculpt neighboring clouds, sometimes stimulating further clumping and star birth at the cloud's edges. It's an intricate cycle, star death leading to star birth, a cosmic phoenix rising from the ashes. Through this ongoing cycle, the galaxy's supply of gas gradually diminishes, but it ensures that successive generations of stars are born with the gifts of their ancestors already inside. By now, it's clear that stars are not isolated points of light. They are the central actors in the great story of the cosmos. They sculpt galaxies with their collective light and their winds and explosions. They forge nearly every chemical element heavier than helium in their cores or in their fiery deaths. And they create the conditions for planets to form around them in the leftover disks of their birth. From those planets, beings like us can eventually emerge, beings made of star stuff, who then look back and ponder the stars. Our Earth coalesced around a second or third generation star, the Sun, about 9 billion years into the universe's timeline. It carries in its rocks and living organisms the fingerprints of countless stars before us. The silicon in the sand, the phosphorus in our DNA, the sodium and chlorine in the oceans. Those atoms were fashioned long ago in stellar furnaces and then scattered across space. eventually to become part of this planet. The heavy elements from bygone stars now circulate in our blood and build our cities. We truly are a way for the cosmos to experience itself, as one great scientist put it. When we gaze at the stars, we are literally seeing our own origins. The light from those distant suns allowed Earth to form and life to develop. And now our eyes capture that light and our minds understand it. We have closed a loop in a sense. The stars made us, and we in turn can comprehend and appreciate the stars. It's a humbling and uplifting realization that underscores the unity of everything in the universe. As our journey through the lives of stars comes to an end, picture yourself once more standing beneath a clear, dark night sky. The silence of the night is profound. The only sounds might be the wind or a distant owl. Above, the stars sprinkle the heavens with their gentle light. The Milky Way arches overhead, a faint band made of the amalgamated glow of billions of distant stars. With the knowledge we have gathered, each point of light now carries a story. You can point to a star and think, that might be a middle-aged star like the Sun, with planets orbiting it and perhaps life of its own. Another might be a massive blue giant destined for a short, brilliant life and a dramatic supernova end. That red one there could be a giant star in its final phases, about to shed its husk and reveal a white dwarf. Yet another faint smudge might not be a single star at all, but an entire galaxy far beyond our own, filled with hundreds of billions of stars, each with its own journey. In the stillness of such a night, the weight of this understanding can be awe-inspiring. We stand tiny on a small planet, bathed in the ancient light of stars, connecting us to epochs and places we will never see. The stars evoke not just scientific curiosity, but also a deep emotional response. For thousands of years, humans have looked up in wonder, weaving myths and seeking guidance from the stars. In ancient times, the night sky was humanity's map and calendar. Farmers planted and harvested by the rising of certain stars. Sailors navigated by the star patterns, and every culture filled the sky with stories, images of bears, hunters, dragons, and heroes that gave meaning to those distant lights. The stars have always been our companions in the dark, symbols of permanence, even as we now know they too have life cycles. Now we have peeled back many of their secrets, yet the wonder remains, and has perhaps only grown deeper. We know that those stars are not eternal. They are born, they age, and they die, in an endless cosmic cycle. We know that on some nights, some of the stars we see have already died in reality, but their light is still on its way to us, a messenger from the past. We know that every atom in our body was once inside a star that died long before Earth formed. We are intimately connected to these points of light. They are our stellar ancestors, and in a real sense, we are their children. Such knowledge does not diminish the star's beauty, it amplifies it. When we look up now, we see not just pretty lights, but a grand story unfolding across the vastness. Eventually, even the stars will fade. The universe is dynamic and evolving. Trillions of years from now, the galaxies will exhaust their gas, star formation will cease, and the remaining stars will gradually die out. The cosmos will go dark again, as it was in the beginning, but now filled with the remnants of those stars. White dwarfs turned cold and black, neutron stars, and black holes roaming the darkness. But that far future is almost beyond contemplation. Right now, we live in a universe awash with starlight. It is the golden age of stars, where new ones still form and the night sky still gleams. We are fortunate to witness it. And as long as there are eyes to see and minds to wonder, the stars will never be merely points of light. They will be beacons of meaning, symbols of the enduring cycle of creation and transformation. Stars are the ancestors of everything we know and the architects of the universe's structure. They crafted the elements that form our world and our bodies. They organize themselves into galaxies, the that shape the cosmos on the grandest scales. As we conclude this meditation on stars, we find ourselves back in silence, contemplating the darkness that is now no longer empty. It's filled with the gentle glow of distant stars and galaxies, a cosmic tapestry woven by countless suns. In the great silence of space, the starlight we see continues to journey outward. Even after a star has lived its life and gone, its light remains, traveling through the darkness, carrying the tale of that star's life to faraway places. Right now, above you, photons from stars hundreds of light years away are gently landing on your eyes, having left their homes long before you were born. And those photons will continue past you into the night, on an endless voyage. The universe is silent, but it is not empty. It is filled with the stories of stars, whispered in the language of light. And so we end where we began, with darkness and quiet. But now we know that in that darkness, light is always traveling. The stars, our brilliant ancestors and cosmic architects, shine on, and in the quiet darkness, their light continues its eternal journey. In the silent darkness of space, their starlight continues to travel, carrying their story across the cosmos forever.